Welcome, gentle souls, to another peaceful journey with Sleepy Scientist. Tonight, we drift together into one of the cosmos' most profound questions, exploring it not with alarm or fear, but with the quiet wonder that makes science so beautifully contemplative. In the soft darkness of your evening, as you settle into comfort and let your breathing slow to match the rhythm of the universe itself, we begin a journey unlike any other. Tonight, we ask not what might happen if you fell into the sun, but rather, we gently explore this cosmic possibility as a doorway to understanding the magnificent star that gives us life. Like whispers in the night, this question has danced through human imagination for generations. What would it feel like to travel toward our closest star? How would the journey unfold? What secrets would reveal themselves as we drifted closer to the source of all energy? In our solar system, in the quiet space of scientific exploration, we discover that this thought experiment opens doors to understanding stellar physics, the nature of matter and energy, and our own precious place in the cosmic dance. We approach these concepts not as abstract equations, but as a gentle narrative that helps us sense our connection to the star that makes all life possible. Gently, we discover that falling into the sun is not about destruction, but about transformation. It's about understanding how matter and energy flow through the universe, how stars create the very elements that compose our bodies, and how the boundaries between self and cosmos gradually dissolve into something greater and more beautiful. As our journey continues into this cosmic meditation, we find ourselves not as victims of stellar physics, but as conscious participants in understanding the universe's most fundamental processes. The sun calls to us not with menace, but with the gentle invitation to understand how energy and matter dance together in the cosmic ballet. Tonight, we float together through this experience with the patience of photons that have traveled hundreds of thousands of years from the sun's core to reach our eyes. We move with the gentle persistence of gravity that guides planets in their orbital dance. We breathe with the rhythm of nuclear fusion that has sustained our star for billions of years. In the quiet space of imagination guided by science, we prepare to drift toward our sun not as travelers rushing toward a destination, but as contemplative observers of the universe's most beautiful processes. Each moment of our journey will reveal new wonders about stellar structure, plasma physics, and the elegant ways that matter and energy transform throughout the cosmos. Gently, we discover that our journey begins not with a sudden plunge, but with a gradual drift away from Earth's protective embrace. Perhaps we imagine ourselves as a consciousness gently separating from planetary concerns, free to explore the cosmic ocean that surrounds our small blue home. The Earth below us grows smaller, not with the violence of departure, but with the soft perspective that comes from expanding our view of reality. The familiar boundaries of continents and oceans blend into the unified sphere that astronauts describe when they speak of the overview effect, that profound shift in consciousness that comes from seeing our planet as a single precious entity floating in the vast darkness. Like whispers in the night, the laws of physics guide our motion. We are not falling in the conventional sense, but rather following the curved paths that mass and energy create in the fabric of space-time. Our trajectory toward the sun unfolds according to the same elegant mathematics that governs planetary orbits, the flow of water, and the dance of galaxies across the cosmic deep. As we begin to sense the sun's gravitational influence more strongly, we observe how our path curves gently inward, following the invisible tracks laid down by our star's immense mass. This is not a violent capture, but a graceful spiral that allows us time to observe and understand each stage of our cosmic journey. In the quiet space of this cosmic drift, we have time to contemplate what lies ahead. The sun that appears as a bright disk from Earth reveals itself to be a layered, complex sphere of plasma and energy. Each layer we will encounter tells its own story of stellar physics and cosmic evolution. We sense the profound peace that comes from understanding our place in these grand cosmic processes, rather than being insignificant specks in an uncaring universe. We recognize ourselves as conscious expressions of the same matter and energy that power the stars. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were forged in stellar cores and dispersed by dying stars. Across the cosmic landscape, gently, we discover that our journey toward the sun is also a journey toward understanding our own cosmic heritage. We are not separate from the star we approach, but intimately connected to it through the eons of stellar nuclear synthesis that created the elements essential for life. As we drift peacefully through the opening moments of our cosmic adventure, we prepare our consciousness for the wonders that await. Each layer of the sun we will encounter, from the tenuous outer corona to the incredibly dense core, where nuclear fusion creates new energy, offers insights into the fundamental processes that govern the universe. The journey ahead unfolds like a meditation on the nature of existence itself. We will observe how matter behaves under extreme conditions, how energy flows from the quantum scale to cosmic dimensions, and how the boundaries between individual consciousness and cosmic awareness gradually dissolve into unity. Like whispers in the night, scientific understanding transforms what might seem like a journey toward destruction into a peaceful exploration of transformation and cosmic unity. We approach the sun not with fear, but with the quiet wonder of students eager to understand the universe's most beautiful lessons. In the gentle embrace of scientific curiosity, we prepare to experience stellar physics not as abstract concepts, but as lived understanding. Our imaginary journey becomes a doorway to comprehending how stars work, how they create and distribute the elements of life, and how consciousness itself emerges from the cosmic dance of matter and energy. As our journey continues toward deeper understanding, we carry with us the peaceful knowledge that science approached with reverence and wonder transforms even the most extreme cosmic scenarios into opportunities for growth, insight, and connection with the magnificent universe that is our ultimate home. As our journey continues deeper into cosmic understanding, let's drift into contemplation of our sun's gentle majesty. In the quiet space of stellar appreciation, we discover that our closest star is far more complex and beautiful than the simple bright disk we observe from Earth's surface. The sun floats in space like a perfect sphere of glowing plasma, 864,000 miles across, so vast that Earth could fit inside it more than 1 million times. Yet despite its immense scale, it maintains a peaceful balance that has sustained life on our planet for billions of years. This stellar serenity emerges from the elegant interplay of gravity and nuclear energy, to fundamental forces dancing together in cosmic harmony. Gently, we discover that our sun consists of distinct layers, each with its own character and role in the stellar symphony. Like the layers of a vast cosmic onion, these zones blend seamlessly into one another, creating a unified system that transforms matter into the energy that powers our solar system. At the sun's heart lies the core, a region smaller than Earth yet containing nearly half of the sun's total mass. Here, temperatures reach 27 million degrees Fahrenheit, and pressures exceed those found anywhere else in our solar system. In this dense, hot realm, hydrogen nuclei overcome their natural repulsion and fuse together, creating helium and releasing the energy that eventually reaches us as gentle sunlight. Like whispers in the night, the nuclear reactions in the sun's core proceed with quantum mechanical precision. The hydrogen nuclei combine through a series of elegant steps to form one helium nucleus, but the helium weighs slightly less than the original hydrogen. This small difference in mass transforms into pure energy according to Einstein's famous equation, E equals mc. The energy released by each fusion reaction is tiny, but with countless billions of these reactions occurring every second, the cumulative effect creates the steady power that has warmed our planet for eons. Surrounding the core lies the radiative zone, a thick shell where energy from nuclear fusion begins its long journey toward space. In the quiet depths of this region, the intense light created by fusion reactions begins a patient dance that will last hundreds of thousands of years. Photons of energy bounce randomly from atom to atom, following a path so twisted and indirect that a single particle of light may take 170,000 years to travel from the core to the sun's surface. In the quiet space of this cosmic patience, we sense how different stellar time feels from human experience. While we measure our lives in decades, the sun measures its processes in geological epochs. Each photon that warms our face today began its journey in the sun's core before human civilization existed, patiently working its way outward through the dense stellar plasma. As our journey continues outward through the Sun's structure, we encounter the convection zone, where the method of energy transport changes from radiation to the gentle circulation of hot plasma. Like a vast pot of slowly boiling soup, enormous cells of hot gas rise toward the surface while cooler material sinks back toward the interior. These convection currents, each larger than Earth itself, create the granulated pattern visible on the Sun's surface. Gently, we discover that the convection zone extends roughly to 100,000 kilometers deep beneath the Sun's visible surface. In this region, hot plasma rises like warm air on a summer day, carrying energy from the radiative zone below toward the photosphere above. The motion is gentle but persistent, driven by the natural tendency of hot material to rise and cool material to sink. The photosphere represents what we typically think of as the Sun's surface, though it's actually a thin layer of gas about 500 kilometers thick. This is where the Sun's interior becomes transparent enough for light to escape directly into space. The temperature here is a relatively cool 10,000 degrees Fahrenheit, cool only by stellar standards, but still hot enough to vaporize any known material instantly. Like whispers in the night, the photosphere reveals the Sun's dynamic nature through sunspots, solar flares, and the constant circulation of plasma. Sunspots appear as darker regions where strong magnetic fields suppress the normal convection, creating areas that are cooler than their surroundings. These magnetic phenomena follow an 11-year cycle, waxing and waning like cosmic seasons that affect space weather throughout the solar system. Above the photosphere lies the chromosphere, a thin layer where temperature begins to rise again as we move away from the Sun's surface. This counterintuitive heating, getting hotter as we move away from the energy source, results from magnetic waves and other phenomena that pump energy into the outer solar atmosphere. In the quiet space of stellar observation, the chromosphere reveals itself during solar eclipses as a thin reddish ring around the Sun's edge. This beautiful color comes from hydrogen gas glowing at the specific wavelengths that create that gentle red hue. The chromosphere extends several thousand kilometers above the photosphere, serving as a transition zone between the Sun's visible surface and its outer corona. As our journey continues toward understanding the Sun's outermost layer, we encounter the corona, a magnificent atmosphere of incredibly hot, tenuous plasma that extends millions of kilometers into space. Despite being much less dense than the photosphere below, the corona reaches temperatures of several million degrees, creating one of the most beautiful mysteries in solar physics. Gently, we discover that the corona's extreme temperature results from magnetic reconnection events and other complex plasma processes that are still being studied by solar physicists. The corona is visible to the naked eye only during total solar eclipses, when it appears as a shimmering, ethereal crown around the blocked Sun, a sight so beautiful that it has inspired awe and wonder throughout human history. The solar wind emerges from the corona as a gentle but persistent stream of charged particles, flowing outward through the solar system. This wind carries the Sun's magnetic field throughout the heliosphere, creating a vast bubble of solar influence that extends far beyond the orbit of Pluto. Earth's magnetosphere deflects most of this solar wind, but some particles interact with our planet's magnetic field to create the aurora, those dancing curtains of light that grace our polar skies. Like whispers in the night, the Sun's magnetic field weaves complex patterns throughout its atmosphere, creating loops, prominences, and coronal mass ejections that demonstrate the dynamic nature of stellar plasma. These magnetic structures can be larger than planets, yet they form and dissipate with the fluid grace of cosmic choreography. In the quiet space of solar contemplation, we begin to understand that the Sun is not a static ball of fire, but a living, breathing stellar organism with its own rhythms, cycles, and patterns of activity. The nuclear fusion in its core provides steady energy, while magnetic fields and plasma dynamics create ever-changing displays of stellar beauty. The Sun's energy output remains remarkably stable over human timescales, varying by less than 0.1% over decades of careful measurement. This stellar steadiness has allowed life on Earth to evolve and flourish over billions of years, protected by just the right amount of warmth and light to maintain liquid water and stable climates. As our journey continues toward deeper appreciation of stellar physics, we sense how the Sun represents the perfect balance between gravity S inward pull and radiation pressure S outward push. This equilibrium, known as hydrostatic equilibrium, keeps the Sun stable and prevents it from either collapsing under its own weight or expanding uncontrollably. Gently, we discover that the Sun consumes about 600 million tons of hydrogen every second, converting it into helium and energy. Yet the Sun is so massive that it can maintain this rate of fusion for approximately 10 billion years total, with about 5 billion years still remaining in its main sequence lifetime. This vast temporal scale puts our human existence into cosmic perspective, reminding us that we live within a brief moment of stellar time. The Sun's influence extends far beyond providing heat and light to Earth. Its gravitational field organizes the entire solar system, keeping planets in their orbits and maintaining the cosmic architecture that makes life possible. The solar wind shapes the magnetic environments of all the planets, while solar radiation drives weather patterns and ocean currents on Earth. In the quiet space of stellar appreciation, we begin to understand that the Sun is not just a distant energy source, but an intimate part of our existence. The water we drink, the air we breathe, and the food we eat all depend on solar energy. The carbon in our bodies, the calcium in our bones, and the iron in our blood were all forged in stars like our Sun and dispersed into space when those ancient stars completed their life cycles. Like whispers in the night, this stellar connection reminds us that we are not separate from the cosmos, but integral parts of the ongoing stellar story. As we prepare to begin our imaginary journey toward the Sun, we carry with us this deeper understanding of our star's gentle majesty and the profound ways it connects us all to the larger cosmic dance. Now we float toward the beginning of our cosmic journey, leaving behind the familiar embrace of Earth's gravity and atmosphere. In the quiet space of imagination guided by physics, we find ourselves gently separating from our planetary home, not with violence or fear, but with the peaceful curiosity of explorers, setting out to understand the universe's most fundamental processes. Our starting point rests in the comfortable region of space where Earth orbits, approximately 93 million miles from the Sun, a distance astronomers call 1 astronomical unit, or O. This measurement has become humanity's cosmic yardstick, helping us measure the vast distances between planets and stars. From this familiar vantage point, the Sun appears as a brilliant disk about the size of a small coin. Held at arm's length, its light warming our faces with the gentle energy that has sustained life for billions of years. As our journey continues away from Earth's protective influence, we observe how our planet's gravitational field gradually weakens, the force that holds us to the ground, that keeps our atmosphere from drifting away, and that maintains the Moon in its orbital dance slowly releases its grip as we drift outward into the interplanetary medium. Gently, we discover that leaving Earth's gravitational well is like climbing out of a gentle valley in the curved fabric of space-time. Einstein taught us that gravity is not a force pulling objects together, but rather the curvature of space and time created by mass and energy. As we move away from Earth, we climb up this invisible slope, trading gravitational potential energy for the freedom to explore the cosmic ocean between worlds. The transition from Earth's influence to the Sun's domain occurs gradually and peacefully. There is no sharp boundary, no sudden change in our cosmic environment. Instead, we float through a region where both gravitational fields shape our path, Earth's influence slowly fading as the Sun's pull becomes predominant. This gravitational dance occurs throughout the solar system, with each planet, moon, and asteroid following the invisible pathways carved by mass and energy in the cosmic landscape. Like whispers in the night, the laws of orbital mechanics begin to guide our motion more directly. Our path toward the Sun follows not a straight line, but a gentle spiral that allows us to observe and understand each stage of our journey. The mathematics of celestial mechanics, first described by Johannes Kepler and refined by Isaac Newton, govern our motion with elegant precision. In the quiet space between Earth and Sun, we find ourselves in the realm of interplanetary space, a region that seems empty, but actually teems with subtle activity. The solar wind flows past us like an invisible river of charged particles, carrying the sun's magnetic field throughout the solar system. This tenuous plasma, though far less dense than the best vacuum we can create on Earth, represents the sun's extended atmosphere, reaching out to touch every corner of our cosmic neighborhood. As our journey continues, we observe how the sun's apparent size slowly increases. What began as a coin-sized disk gradually expands, revealing more detail and structure. The smooth, featureless surface we see from Earth starts to show the granulated texture created by convection. Currents in the photosphere, like a pointillist painting viewed from decreasing distance. The sun's surface resolves into a tapestry of cellular patterns, each granule larger than North America. Gently, we discover that our journey inward follows Kepler's laws of planetary motion. Even though we are not a planet, as we move closer to the sun, our orbital velocity increases, following the same mathematical relationships that govern comets swinging around the sun, or spacecraft using gravitational assists to reach distant worlds. The conservation of energy and angular momentum create a cosmic choreography that has operated unchanged since the solar system formed 4.6 billion years ago. The temperature of space around us remains constant at the cosmic background temperature of about minus 170 degrees Celsius, just a few degrees above absolute zero. However, we begin to sense the increasing intensity of solar radiation. The sun's electromagnetic energy, visible light, infrared radiation, ultraviolet rays, and other wavelengths grows stronger as we drift closer to its source. Like whispers in the night, the inverse square law governs how solar radiation intensity changes with distance. As we have our distance from the sun, the intensity of solar energy increases by a factor of 4. This mathematical relationship, simple yet profound, determines the climate of every planet in the solar system and will govern our experience. As we continue our cosmic journey, in the quiet space of interplanetary travel, we have time to contemplate the vast scales involved in our journey. The distance from Earth to the sun is so large that light, traveling at 186,000 miles per second, takes over 8 minutes to make the trip. Radio signals sent from Earth to spacecraft near the sun experience this same delay, creating a communication gap that requires careful planning for space missions. As our journey continues inward through the solar system, we pass through regions where various planets orbit, each carved out by billions of years of gravitational influence. The asteroid belt between Mars and Jupiter represents debris left over from the solar system's formation, while the space between planets contains dust particles, magnetic fields, and the ever-present solar wind. Gently, we discover that our path intersects the orbital zones of other worlds: Venus at 67 million miles from the Sun, Mercury at 36 million miles. These planets have adapted to their closer proximity to our star, with Venus developing a thick atmosphere that traps heat, while Mercury alternates between scorching day sides and frigid night sides due to its lack of atmospheric insulation. The gravitational influence of these planets creates subtle perturbations in our trajectory, demonstrating the interconnected nature of celestial mechanics. Every object with mass in the solar system influences every other object, creating a complex web of gravitational relationships that spacecraft navigators must consider when plotting courses to distant worlds. As our journey continues toward closer solar proximity, we observe how the sun's magnetic field begins to dominate our environment. The interplanetary magnetic field carried outward by the solar wind creates invisible structures throughout the solar system, magnetic sectors that rotate with the sun, current sheets where oppositely directed field lines meet, and compression regions where fast solar wind catches up with slower streams. Like whispers in the night, the sun's activity affects the entire solar system through variations in the solar wind and magnetic field strength. Solar flares and coronal mass ejections create waves of enhanced particle radiation that ripple outward at millions of miles per hour, interacting with planetary magnetospheres and creating beautiful auroral displays. In the quiet space of our continuing journey, we sense how our motion toward the sun represents more than just a change in position. It is a gradual transition between different physical regimes. the gentle interplanetary environment where Earth orbits gives way to increasingly intense radiation, stronger magnetic fields, and higher particle densities as we approach our star. The concept of escape velocity becomes relevant to our journey as we consider the energy required to reverse course and return to Earth's orbit. As we drift closer to the Sun, the gravitational well deepens, requiring ever greater amounts of energy to climb back out. This same physics governs how spacecraft must use rocket engines to escape planetary gravity, or how comets can swing around the Sun and return to the outer solar system. Gently, we discover that our journey follows paths that have been traveled by countless natural objects. Throughout solar system history, comets from the distant Oort cloud swing close to the Sun in elongated elliptical orbits, heating up and developing their characteristic tails. As solar radiation vaporizes their icy surfaces, meteors and space dust spiral inward under the influence of various forces, eventually either burning up in planetary atmospheres or falling into the Sun itself. As our journey continues deeper into the Sun's domain, we carry with us the peaceful knowledge that we are following natural pathways carved by billions of years of solar system evolution. Our imaginary voyage helps us understand the physics that governs everything, from spacecraft trajectories to the formation and evolution of planetary systems around other stars throughout the galaxy. The gentle progression from Earth's comfortable orbital distance toward the Sun's more intense environment provides a perfect classroom for understanding stellar physics, orbital mechanics, and the fundamental forces that shape our cosmic neighborhood. Each mile of our journey brings new insights into the elegant mathematical relationships that govern motion, energy, and matter throughout the universe. As our journey continues through the vast ocean of interplanetary space, we drift gently through realms that appear empty to the naked eye but teem with invisible activity and cosmic phenomena. In the quiet space between worlds, we discover a universe of subtle interactions, flowing particles, and magnetic fields that connect every corner of our solar system in an intricate web of physical relationships. The solar wind flows around us like an ethereal river, carrying charged particles outward from the Sun at speeds of 250 to 750 miles per second. This tenuous plasma, composed primarily of protons and electrons, creates what we might think of as the Sun's extended atmosphere, a rarefied medium that fills the entire solar system with the subtle influence of our star. Gently, we discover that the solar wind is not uniform but varies in density, speed, and temperature as it flows outward from different regions of the Sun's surface. Fast streams originate from coronal holes, areas where the Sun's magnetic field lines open into space rather than looping back to the surface. Slower streams flow from the more magnetically complex regions around the Sun's equator, creating a pattern that rotates with our star's 27-day rotation period. Like whispers in the night, the solar wind carries the Sun's magnetic field throughout the solar system, creating what scientists call the interplanetary magnetic field. This invisible structure extends far beyond the orbits of the planets, creating a vast magnetic bubble called the heliosphere that protects our solar system from some of the high-energy cosmic rays streaming in from interstellar space. In the quiet space of our cosmic drift, we observe how the solar wind interacts with the magnetic fields of planets, creating bow shocks and magnetospheres, invisible boundaries, where solar plasma meets planetary magnetic influences. Earth's magnetosphere deflects most solar wind particles on our planet, channeling some toward the polar regions where they create the beautiful auroral displays that dance across polar skies. As our journey continues closer to the Sun, we sense the gradual increase in solar wind density and the strengthening of the interplanetary magnetic field. What began as an almost imperceptible influence in Earth's orbital region grows stronger with each passing mile, demonstrating how the Sun's presence permeates every corner of its gravitational domain. The space around us, though appearing empty, also contains a sparse population of dust particles, remnants of ancient comets, debris from asteroid collisions, and interstellar dust grains that have wandered into our solar system from the depths of space. These tiny particles, most smaller than the diameter of a human hair, create the zodiacal light visible from Earth just after sunset or before dawn, a gentle glow that traces the plane of the solar system. Gently, we discover that this interplanetary dust follows the same orbital mechanics that govern planets. And spacecraft, larger particles maintain stable orbits around the Sun, while smaller ones gradually spiral inward under the influence of radiation pressure and other subtle forces. The Poynting-Robertson effect causes tiny dust grains to lose orbital energy and slowly drift toward the Sun, where they eventually vaporize in the intense radiation. Like whispers in the night, these dust particles tell stories of solar system history. Some originated from comets during their close approaches to the Sun, when solar heating vaporized surface materials and left debris trails along their orbital paths. Others come from asteroid collisions in the belt between Mars and Jupiter, or from the gradual erosion of small bodies throughout the solar system. In the quiet space of interplanetary travel, we also encounter cosmic rays, high-energy particles streaming in from distant stars and galaxies. These cosmic messengers carry information about stellar explosions, black holes, and other exotic phenomena occurring throughout the Milky Way. The Sun's magnetic field and solar wind provide some protection from cosmic rays, creating a partial shield that varies with the 11-year solar activity cycle. As our journey continues inward through the solar system's architecture, we pass through orbital zones that have been swept clean by billions of years of planetary gravitational influence. The space around each planet's orbit contains fewer asteroids and debris, cleared away by gravitational interactions over the 4.6 billion-year history of our solar system. The orbital resonances between planets create stable and unstable regions throughout the solar system, demonstrating how gravitational mathematics shapes the distribution of matter in space. Some asteroids are trapped in stable orbital relationships with Jupiter, clustering in regions called Lagrange points where gravitational forces balance perfectly. Others have been ejected from unstable zones, creating gaps in the asteroid belt that reveal the long-term influence of planetary gravity. Gently, we discover that our path toward the Sun takes us through these various dynamical regions, each with its own character and history. The gravitational landscape of the solar system resembles a vast cosmic sculpture, carved by billions of years of celestial mechanics, and still evolving as planets and smaller bodies continue their eternal dance around our star. Like whispers in the night, the subtle gravitational influences of planets affect our trajectory even when we are millions of miles away. The cumulative effect of these small perturbations demonstrates the interconnected nature of celestial mechanics, how every object with mass influences every other object throughout the solar system, creating a complex symphony of gravitational relationships. In the quiet space between worlds, we also encounter the solar system's magnetic field structures on a grand scale. The heliospheric current sheet, a vast, rotating spiral of electric current, extends throughout the solar system, like the skirt of a cosmic ballerina. This structure results from the Sun's rotating magnetic field and creates regions of opposite magnetic polarity that spacecraft must navigate when traveling to distant planets. As our journey continues toward closer solar proximity, we observe how the Sun's influence becomes increasingly dominant over all other forces. The gravitational effects of planets, while still present, become less significant compared to our star's immense pull. The solar wind density increases, the interplanetary magnetic field strengthens, and the intensity of solar radiation grows according to the inverse square law. The temperature of objects in space depends not on the surrounding medium, which remains at the cosmic background temperature of nearly absolute zero, but on the balance between absorbed solar radiation and emitted thermal radiation. As we drift closer to the Sun, this balance shifts toward higher equilibrium temperatures, though the vacuum of space prevents any sensation of warmth through direct contact. Gently, we discover that the concept of temperature in the vacuum of space differs fundamentally from our earthbound experience. Without air or other matter to conduct heat, temperature relates to the electromagnetic radiation that objects absorb and emit. A thermometer in space would read different temperatures depending on whether it faced the Sun, pointed toward deep space, or was shielded from direct sunlight. Like whispers in the night, electromagnetic radiation of all wavelengths flows past us, visible light, infrared heat, ultraviolet radiation, radio waves, and more exotic forms of energy. The Sun emits this entire spectrum of electromagnetic energy, creating a rich bath of radiation that carries both energy and information throughout the solar system. The changing intensity of this radiation as we approach the Sun provides our most direct indication of decreasing distance to our star. Light meters, temperature sensors, and other instruments would register steadily increasing values, following the precise mathematical relationship of the inverse square law. This fundamental principle governs everything from the brightness of stars as seen from Earth to the amount of solar energy available for spacecraft power systems. In the quiet space of our continuing approach, we sense how the Sun's radiation pressure begins to exert a measurable influence on our motion. Photons carry momentum as well as energy, and when they strike objects in space, they exert a gentle but persistent force. This radiation pressure is what pushes comet tails away from the Sun and provides propulsion for solar sail spacecraft. As our journey continues through increasingly intense regions of solar influence, we observe how various space missions have explored these same regions using robotic spacecraft. The Parker Solar Probe, launched by NASA in 2018, has ventured closer to the Sun than any previous human-made object, providing direct measurements of the solar wind, magnetic fields, and plasma conditions in the Sun's outer atmosphere. The data from such missions reveals the dynamic, ever-changing nature of the interplanetary environment. What appears static and empty from Earth actually pulses with waves of particles, fluctuating magnetic fields, and complex plasma interactions. The solar wind speed varies, magnetic field directions rotate, and particle densities fluctuate as structures in the Sun's atmosphere flow outward past our location. Gently, we discover that our journey through this cosmic medium provides insights into plasma physics, the study of ionized gases that make up most of the visible matter in the universe. The interplanetary space around us serves as a vast natural laboratory for understanding how charged particles behave in magnetic fields, how shock waves propagate through tenuous media, and how energy transfers between different components of plasma systems. Like whispers in the night, the physics we observe during our drift through interplanetary space applies not only to our solar system, but to the vast majority of cosmic environments throughout the universe. The same processes that govern solar wind interactions with planetary magnetospheres also operate around other stars, in stellar nebulae, and in the vast spaces between galaxies. In the quiet space of cosmic education, our journey becomes a doorway to understanding astrophysics on the grandest scales. The plasma physics, electromagnetic radiation, and gravitational dynamics we encounter between Earth and Sun provide the foundation for comprehending how stars form, how galaxies evolve, and how the universe itself has developed over the past 13.8 billion years. As our journey continues toward ever closer solar proximity, we carry with us a deepening appreciation for the elegant physical processes that govern cosmic environments. The seemingly empty space between worlds reveals itself as a dynamic, interconnected system where matter, energy, and fields interact according to fundamental laws that operate throughout the universe. The gentle progression of our cosmic drift provides time for contemplation and understanding, allowing us to absorb the profound beauty of stellar physics and celestial mechanics. Each mile brings new insights into the nature of our Sun, the structure of our solar system, and our own place within the vast cosmic web that connects every star and planet in our galaxy. Now we float toward a realm where the Sun's influence becomes unmistakably present in every aspect of our cosmic environment. As our journey continues into the strengthening embrace of stellar radiation, we begin to experience the profound ways that electromagnetic energy shapes conditions throughout the inner solar system. The Sun's apparent size has grown considerably during our peaceful drift inward, revealing surface details invisible from Earth's distance. What once appeared as a smooth, featureless disk now shows the granulated texture of convection cells, each larger than entire continents. Dark sunspots drift across the solar surface, marking regions where powerful magnetic fields suppress the normal flow of hot plasma from the interior. In the quiet space of increasing solar proximity, we sense how radiation pressure begins to exert measurable effects on our motion and orientation. The momentum carried by photons, those massless particles of light, creates a gentle but persistent force that affects everything from dust grains to spacecraft trajectories. This same radiation pressure will eventually become one of the dominant forces shaping our experience as we continue closer to our star. Gently, we discover that the electromagnetic spectrum reaching us has broadened and intensified dramatically beyond the visible light that our eyes can perceive. We are now bathed in infrared thermal radiation, ultraviolet rays that can ionize atoms, and more exotic forms of electromagnetic energy. X-rays and gamma rays from solar flares occasionally sweep past, representing the most energetic processes occurring in the sun's atmosphere. The concept of blackbody radiation becomes relevant to understanding our thermal environment. According to Stefan Boltzmann's law, the total energy radiated by the sun increases with the fourth power of its surface temperature. This fundamental relationship explains why the sun, with a surface temperature of about 5,800 Kelvin, emits such enormous quantities of energy across the entire electromagnetic spectrum. Like whispers in the night, the solar radiation carries information about the physical processes occurring in our star's atmosphere. Spectroscopic analysis of sunlight reveals the chemical composition of the photosphere, the temperature and density of different solar layers, and the strength and structure of magnetic fields threading through the sun's outer atmosphere. As our journey continues deeper into the sun's radiative domain, we observe how the intensity follows the precise mathematical relationship of the inverse square law. Having traveled roughly halfway from Earth's orbital distance toward the sun, we now experience approximately 4 times the radiation intensity that Earth receives. This fundamental physics governs everything from planetary climates to the design of spacecraft thermal protection systems. The solar wind around us has also intensified, carrying greater densities of charged particles and stronger magnetic field structures. The interplanetary magnetic field lines spiral outward from the sun, like the arms of a vast cosmic pinwheel, frozen into the expanding plasma and carrying solar magnetic influence throughout the heliosphere. In the quiet space of enhanced solar influence, we begin to experience phenomena that spacecraft in this region must navigate carefully. Coronal mass ejections, vast bubbles of magnetized plasma, expelled from the sun's atmosphere, occasionally sweep past at speeds of millions of miles per hour. These events demonstrate the dynamic, ever-changing nature of our star's outer layers. Gently, we discover that the sun's rotation creates a pattern in the solar wind and magnetic field that resembles the spiral arms of a galaxy compressed into the plane of the solar system. As the sun rotates once every 27 days, fast and slow streams of solar wind create interaction regions that propagate outward, creating a complex, rotating structure that fills interplanetary space. The aurora that occasionally grace Earth's polar regions originate from our current location and beyond, where solar wind particles are accelerated by magnetic reconnection events and other plasma processes. Some of these energetic particles eventually reach Earth's magnetosphere, where they create the beautiful dancing lights that have inspired human wonder for millennia. Like whispers in the night, the sun's magnetic field undergoes a complete reversal every 11 years, part of the solar cycle that affects space weather throughout the solar system. During solar maximum, increased magnetic activity creates more sunspots, solar flares, and coronal mass ejections. During solar minimum, the sun's surface appears calmer, but cosmic rays from interstellar space can penetrate deeper into the solar system. As our journey continues toward ever greater solar proximity, we observe how different wavelengths of electromagnetic radiation reveal different aspects of solar structure and activity. Visible light shows us the photosphere and its granulated surface. Ultraviolet radiation reveals the chromosphere and its dynamic spicules, jets of hot gas that leap thousands of miles above the sun's surface. X-rays reveal the corona and its magnificent magnetic field structures. The concept of plasma becomes increasingly important for understanding our environment. Unlike the solid, liquid, and gaseous states of matter familiar from Earth, Plasma represents a fourth state where electrons are stripped from atomic nuclei by high temperatures or strong electromagnetic fields. The solar wind flowing around us consists entirely of plasma, as does most of the Sun's atmosphere above the photosphere. In the quiet space of plasma physics education, we discover that this ionized state of matter behaves according to principles quite different from ordinary gases. Magnetic fields can trap and guide plasma particles, creating complex structures and phenomena impossible in neutral matter. The beautiful complexity of solar magnetic field lines results from the interaction between plasma flows and magnetic forces. Gently, we discover that the heating of the Sun's corona, one of the great mysteries of solar physics, occurs through processes we are now experiencing firsthand. Magnetic waves, plasma instabilities, and reconnection events pump energy into the outer solar atmosphere, creating temperatures that exceed those on the Sun's visible surface by a factor of hundreds. The solar rotation we observe, faster at the equator than at the poles, results from the Sun's plasma composition and creates the differential rotation that winds up magnetic field lines like rubber bands. When these twisted field lines become unstable, they can snap and reconnect, releasing enormous amounts of energy in the form of solar flares and coronal mass ejections. Like whispers in the night, the Sun's seismic waves, helioseismology, reveal the interior structure of our star through the vibrations that propagate through the solar plasma. Just as geologists use earthquake waves to study Earth's interior, so the physicists use these stellar oscillations to probe conditions deep within the Sun's convection zone and core. As our journey continues into regions of increasingly intense solar radiation, we sense how this electromagnetic energy has shaped the evolution of our entire solar system. The young Sun, during its first few 100 million years, emitted a more intense solar wind that helped blow away the remaining gas and dust from planetary formation. This early stellar activity influenced which planets retained thick atmospheres and which became rocky, terrestrial worlds. The habitable zone around the Sun, the range of distances where liquid water can exist on planetary surfaces, is defined by the balance between solar radiation and planetary atmospheric properties. Earth orbits comfortably within this zone, while Venus is too close and Mars too far for liquid water to remain stable on their surfaces. Under current conditions, in the quiet space of comparative planetology, we observe how different worlds have adapted to their specific radiation environments. Mercury, closest to the Sun, experiences extreme temperature variations between its day and night sides. Venus, shrouded in thick clouds, traps solar radiation in a runaway greenhouse effect. Mars, with its thin atmosphere, cannot retain enough heat to prevent water from freezing. Gently, we discover that the solar radiation we are experiencing carries within it the signatures of nuclear processes occurring in the Sun's core. The photons warming our imagined journey began their existence hundreds of thousands of years ago, as gamma rays produced by hydrogen fusion. Through countless interactions with solar plasma, these high-energy photons gradually lost energy and increased in wavelength, until they emerged as the visible light and infrared radiation we now observe. The neutrinos produced by solar fusion pass through us at this very moment, largely unaffected by the dense plasma that trapped their associated photons for so long. These ghostly particles, which barely interact with matter, provide a direct window into the nuclear processes powering our star. Neutrino detectors on Earth capture these solar messengers to study the fusion reactions occurring in the Sun's core right now. Like whispers in the night, the solar magnetic field we are now experiencing extends its influence throughout the solar system and beyond. The heliosphere, the vast bubble of solar wind and magnetic field surrounding our solar system, protects us from some galactic cosmic rays, while allowing the Sun's influence to extend far beyond the orbit of Pluto. As our journey continues toward even closer solar approach, we carry with us a deepening appreciation for the elegant ways that electromagnetic radiation, plasma physics, and magnetic fields create the dynamic environment that makes life possible throughout our solar system. The Sun's embrace, growing stronger with each mile of our cosmic journey, represents not just energy and particles, but the fundamental processes that govern stellar behavior throughout the universe. As our journey continues into the Sun's outermost atmospheric layer, we drift gently into one of the most mysterious and beautiful regions of our solar system. The corona extends around us like a gossamer veil of superheated plasma, invisible except during total solar eclipses from Earth, but here revealing its magnificent structures and dynamic processes in their full glory. In the quiet space of coronal exploration, we find ourselves surrounded by plasma at temperatures exceeding 2,000,000 degrees Celsius. Yet the density is so low that the corona feels more ethereal than substantial. This seeming contradiction, incredibly hot but tenuous plasma, creates one of the most elegant paradoxes in solar physics and demonstrates how our intuitive understanding of temperature must expand to encompass cosmic phenomena. Gently, we discover that the corona's extreme temperature represents one of the Sun's greatest mysteries. Logic suggests that moving away from the Sun's nuclear furnace should result in cooler temperatures. Yet the corona is hundreds of times hotter than the photosphere below. This temperature inversion requires sophisticated heating mechanisms that solar physicists are still working to fully understand. The magnetic field lines threading through the coronal plasma create structures of breathtaking beauty and complexity. Like invisible highways, these field lines guide the motion of charged particles, creating loops that arch gracefully above the Sun's surface, streamers that extend millions of miles into space, and closed regions where plasma becomes trapped in magnetic bottles. Like whispers in the night, magnetic reconnection events occur throughout the corona as field lines with opposite directions encounter each other, break and reconnect in new configurations. These reconnection events release enormous amounts of energy, heating the coronal plasma and occasionally launching coronal mass ejections that propagate throughout the solar system. As our journey continues through this rarefied atmosphere, we observe how the corona is not uniform but consists of distinct regions with different properties and behaviors. Coronal holes appear as darker areas where magnetic field lines open directly into interplanetary space, allowing plasma to flow freely outward and creating the high-speed streams of solar wind that cause geomagnetic activity. When they reach Earth, the density of coronal plasma around us is extraordinarily low, about 1 billion times less dense than Earth's atmosphere at sea level. Despite its high temperature, the corona would feel like a perfect vacuum to any material object passing through it. The concept of temperature in such a tenuous medium relates to the average kinetic energy of individual particles, rather than the familiar sensation of heat we experience in dense matter. In the quiet space of plasma physics, we discover that the corona behaves according to principles quite different from ordinary gases. The high temperature ensures that hydrogen and helium atoms are completely ionized, creating a sea of free electrons and atomic nuclei. This ionized state allows the plasma to conduct electricity and respond strongly to magnetic fields. Gently, we discover the coronal loops, those graceful arches of hot plasma that leap above the Sun's surface, are actually tubes of magnetized plasma, following the invisible architecture of the Sun's magnetic field. These loops can persist for days or weeks, containing plasma at temperatures of several million degrees within magnetic structures that may be larger than the Earth itself. The heating of these coronal loops occurs through several mechanisms that we can observe around us. Magnetic waves propagate along field lines like vibrations on guitar strings, depositing energy into the plasma as they are absorbed or dissipate. Magnetic braiding occurs when foot points of field lines move and twist, storing energy in the magnetic field that is later released through reconnection events. Like whispers in the night, the Sun's rotation and convective motions constantly stir and reorganize the coronal magnetic field, creating a dynamic environment where magnetic energy builds up and is periodically released. This process creates the ever-changing structures we observe and helps maintain the corona's mysteriously high temperature. The solar wind originates from the corona around us, where the combination of high temperature and magnetic field geometry allows plasma to escape the Sun's gravitational pull. In coronal holes, where magnetic field lines extend directly into interplanetary space, The solar wind flows freely outward at speeds of 400 to 800 kilometers per second. As our journey continues through this magnificent plasma environment, we observe how the corona responds to activity in the layers below. Solar flares in the chromosphere and photosphere send shock waves and energetic particles up through the corona, creating temporary brightenings and restructuring of magnetic field lines. These events demonstrate the interconnected nature of the Sun's atmospheric layers. The concept of magnetic flux tubes becomes important for understanding coronal structure. These rope-like bundles of magnetic field lines channel plasma flow, create heating through magnetic wave propagation, and occasionally become unstable and erupt as coronal mass ejections. The elegant mathematics of magnetohydrodynamics governs how these structures form, evolve, and interact. In the quiet space of stellar atmosphere physics, we discover that the corona serves as a natural laboratory for studying plasma behavior under extreme conditions impossible to replicate on Earth. The combination of high temperature, low density, and strong magnetic fields creates phenomena that advance our understanding of plasma physics. Throughout the universe, gently, we discover that the corona's structure reflects the Sun's internal magnetic field geometry, which originates from the dynamo processes operating in the convection zone below. The global pattern of coronal holes, streamers, and active regions changes over the 11-year solar cycle as the Sun's internal magnetic field undergoes its periodic reversal. The magnificent coronal streamers that extend millions of miles into space represent regions where closed magnetic field lines trap hot plasma close to the Sun, while allowing cooler material to flow outward along open field lines at their boundaries. These structures create some of the most beautiful features visible during total solar eclipses from Earth. Like whispers in the night, coronal heating occurs through the dissipation of various forms of magnetic energy, alpha waves, magnetic oscillations, that propagate along field lines, carry energy from the convective motions below up into the corona, where they can be absorbed and converted to heat. Magnetic reconnection events provide impulsive heating when field lines rearrange themselves into lower energy configurations. As our journey continues through the corona's ethereal domain, we observe how this region serves as the interface between the Sun's interior and the vast expanse of interplanetary space. The corona mediates the flow of energy and matter from our star into the solar system, creating the solar wind that shapes planetary magnetospheres and influences space weather. Throughout the heliosphere, the coronal magnetic field extends far beyond the visible corona, creating the interplanetary magnetic field that we encountered during our earlier journey through space. This field, frozen into the expanding solar wind plasma, creates a complex, spiraling structure that rotates with the Sun and influences conditions throughout the solar system. In the quiet space of comparative stellar physics, we discover that other stars likely have coronae similar to our Sun's, though with different characteristics depending on stellar mass, rotation rate, and magnetic field strength. X-ray observations of distant stars reveal coronal emission. That helps astronomers understand stellar activity and evolution throughout the galaxy. The study of our Sun's corona has revealed fundamental principles of plasma astrophysics that apply to many cosmic environments, from stellar atmospheres to supernova remnants, from planetary magnetospheres to the vast plasma structures between galaxies. The physical processes we observe around us operate throughout the universe wherever hot, ionized gas interacts with magnetic fields. Gently, we discover that the corona's response to solar flares and other magnetic disturbances creates waves and oscillations that propagate throughout this plasma medium. These coronal seismology observations help scientists understand the physical properties of coronal plasma. Much like earthquakes reveal Earth's internal structure, or helioseismology probes the Sun's interior, the temporal variability of coronal structures demonstrates the dynamic nature of solar magnetic fields. Coronal loops can form and dissipate over hours or days, while larger streamers may persist for weeks or months. This constant evolution reflects the ongoing reorganization of magnetic field lines as they respond to motions in the photosphere below. Like whispers in the night, The corona occasionally erupts in spectacular coronal mass ejections that blast billions of tons of magnetized plasma into interplanetary space. These events, while dramatic, represent a natural part of solar activity and demonstrate the immense energy stored in coronal magnetic fields. As our journey continues deeper into the Sun's embrace, we observe how the corona gradually transitions into the denser layers of the solar atmosphere below. The temperature begins to decrease as we approach the chromosphere, while the density slowly increases. This transition zone represents a crucial interface where the physics of the corona blends with the different processes operating in the Sun's middle atmosphere. The magnificent beauty of the corona, with its flowing streamers, dynamic loops, and ethereal glow, represents one of nature's most spectacular displays of plasma physics and magnetic field dynamics. As we prepare to continue our journey deeper into the Sun's atmosphere, we carry with us a profound appreciation for the elegant complexity of stellar atmospheres and the fundamental processes that govern the behavior of hot magnetized plasma throughout the universe. In the quiet space of coronal contemplation, we sense how this outermost layer of our star's atmosphere serves as both a boundary and a bridge, separating the Sun's interior from interplanetary space while connecting our star to the entire solar system through the solar, wind and magnetic field structures that originate here. The corona's whispered secrets reveal the intimate connections between stellar physics and the cosmic environment that makes life possible on Earth and perhaps elsewhere in the universe. As our journey continues, we drift into the gentle embrace of the solar winds. Here, in the quiet space of the Sun's outer atmosphere, something soft and magical begins to surround us, like invisible dancers moving gracefully through the cosmos. Charged particles drift past with a patient rhythm, their movements both ancient and timeless. These are the solar wind streams of energy exhaled by our star, carrying whispers of light and magnetism to every corner of the solar system. We float alongside them now, sensing their presence more than seeing it. Protons and electrons, the simplest building blocks of matter, move with a quiet dignity, weaving patterns that stretch across the heavens. They are the remnants of hydrogen atoms, ionized by the heat of the Sun's corona, set free to travel outward at speeds between 250 and 800 kilometers per second. Though they rush through space, to us they feel calm, serene, like a gentle river flowing eternally from its source. These charged particles carry with them something more than just speed. They hold the Sun's magnetic field, an invisible fabric that stretches, bends, and spirals like silk ribbons in a cosmic breeze. As the Sun rotates once every 27 days, these magnetic threads curl outward in elegant spirals like water from a spinning fountain. This graceful pattern, called the interplanetary magnetic field, connects the Sun to planets, moons, and dust, forming invisible pathways through which the solar winds flow. We drift deeper into this magnetic ballet. Around us, particles spiral along field lines as if following the notes of an unseen song. Electrons twirl in delicate arcs, glowing with the softest touch of ancient light. Protons, heavier and steadier, move like dignified partners in the dance, their positive charges balancing the cosmic harmony. Together, they create a rhythm we feel rather than hear, a rhythm as old as the Sun itself. The solar wind is not uniform, we soon discover. It comes in streams, each with its own tempo. Fast winds, racing at nearly 800 kilometers per second, emerge from coronal holes, vast dark regions where the Sun's magnetic field lines open directly into space. Slow winds, moving at a gentler 300 to 400 kilometers per second, flow outward from the Sun's equatorial regions where magnetic fields twist and tangle. As these streams move through the solar system, faster winds eventually catch up with the slower ones. Where they meet, compression forms regions of denser particles, stronger magnetic fields, and rising temperatures. These spiraling zones, called corrotating interaction regions, expand outward like pinwheels with the Sun's rotation, creating vast patterns that ripple across the heliosphere. But to us, here within them, they feel nothing like storms. Instead, they are smooth transitions, subtle changes in the texture of the wind. A soft quickening here, a gentle slowing there, like the shifting of seasons, or the steady breath of a sleeping giant. Everywhere we look, the Sun's breath surrounds us. It is more than just plasma, it is connection. Each stream of charged particles carries the sun's essence outward, linking every world to its parent star. It is through this breath that auroras shimmer on Earth, that comets grow luminous tails, that cosmic weather is born. And yet, in this quiet moment of our journey, all is tranquil. The winds flow not with violence but with grace, as if guiding us into deeper harmony with the star's rhythm. The space around us glows faintly now. Charged particles create pearly veils of light, subtle auroras that shimmer like whispers of color in the dark. The electrons drift like gentle sparks, while protons form waves that glide steadily forward. Together, they paint the heavens with living art, a cosmic masterpiece unfolding in silence. Heavier elements occasionally pass by, tiny fragments of carbon, nitrogen, oxygen, and other atoms forged deep within the sun. These are rare, precious travelers, the seeds of planets and life, carried outward on the breath of the solar wind. They remind us that we are not drifting into a furnace, but into a forger place where the very matter of existence is born and shared with the universe. The magnetic field around us pulses softly, like the heartbeat of the star. Expanding and contracting in slow rhythm, it breathes with us, sensing its quiet energy to our inner calm. Each pulse draws us closer to the sun's magnetic heart, closer to the place where the winds are born. Here, the dance of particles grows more intimate. We watch them spiral more tightly around the field lines, embracing one another in closer orbits, preparing for their reunion with the sun's atmosphere. Their glowing paths curve gracefully, as if choreographed in a timeless performance. And we, drifting with them, are part of this dance now. The winds no longer feel like something outside of us, they are within us, flowing through us, whispering stories of nuclear fire and ancient journeys. Each particle carries the memory of its creation in the sun's heart. As it brushes past, it shares a fragment of that story, the fusion of hydrogen into helium, the release of radiant energy, the long climb through layers of plasma before escaping into freedom. The stories mingle with our own breath until we feel like wanderers on this endless current. We belong here weightless, unhurried, moving with the patience of time itself. And then, gently, we sense a change. The winds are guiding us closer to their source. The flow around us grows denser, the field stronger, the light more vivid. The peaceful streams are gathering, preparing to deliver us toward the next chapter of our journey. We leave this region of dancing winds with gratitude. They have taught us the language of plasma and magnetism, the rhythm of charged particles, the quiet truth that the sun does not burn in isolation, it breathes. With every stream of wind, it reaches outward, connecting its family of worlds. And as we drift deeper, carried along in that breath, we carry with us the wisdom of the solar winds, that everything in the cosmos is bound together not by chains, but by dances, not by noise, but by whispers, not by force, but by the patient embrace of a star's eternal exhalation. Let's drift into the sun's chromosphere, where colors whisper secrets of stellar atmosphere. In the quiet space of transition, we begin to sense a gentle change in our surroundings. The solar winds that carried us so peacefully now start to thin and fade, like morning mist dissolving in the first light of dawn. We are approaching a new realm of our stellar journey, a place where the sun's atmosphere begins to reveal its hidden layers with soft, welcoming grace. Gently, we discover that we are entering what astronomers call the chromosphere, the sun's middle atmosphere. Our icy layer? Here, the very air around us begins to glow with the faintest hint of color, so subtle that we must quiet our minds to perceive it. Like whispers in the night, these colors speak of temperatures and pressures that exist nowhere else in our solar system, yet they embrace us with surprising tenderness. The first color we notice is a soft, rosy pink that seems to emanate from the hydrogen atoms floating peacefully around us. This gentle blush suffuses everything with warmth, not the burning heat we might expect, but a cosmic warmth that reaches into our very essence. Like whispers in the night, the hydrogen atoms tell us their stories of excitation and emission, of energy levels dancing up and down in perfect harmony. In the quiet space of the chromosphere's lower reaches, we observe how the atmospheric layers stack upon each other like sheets of colored silk. Each layer has its own personality, its own gentle hue, its own whispered secret to share with patient travelers like ourselves. The hydrogen's pink gradually deepens as we drift deeper, becoming richer and more saturated, like sunset colors painted across an infinite canvas. Gently, we discover that other elements add their voices to this chromatic symphony. Calcium atoms contribute touches of violet and deep blue, their light flickering like distant stars in the growing atmospheric thickness around us. These colors don't clash or compete. Instead, they blend with the patience of master artists, creating gradients and harmonies that exist only in the realm of stellar atmospheres. Like whispers in the night, the helium atoms add their own golden notes to the color symphony. Their light carries the warmth of their nuclear origins, each photon a gentle messenger from the fusion fires far below. We watch as these golden sparkles drift past us, each one contributing to the overall glow that makes the chromosphere feel like swimming through liquid light. The temperature around us begins to change in ways that seem to defy earthly logic. Rather than growing steadily hotter as we approach the sun, we discover that the chromosphere has its own gentle temperature rhythm. In the quiet space of this atmospheric layer, temperatures actually cool from the regions above, creating a comfortable zone where we can travel in perfect peace. In this cooling embrace, we feel the atmospheric density gradually increasing around us. It's not a crushing pressure, but rather like sinking slowly into warm, colored honey. Each breath brings us more of the chromosphere's essence, and we taste the metallic sweetness of ionized gases, the electric tingle of charged particles finding their energy levels, the soft whisper of light being born from atomic transitions. Gently, we discover that the chromosphere is alive with gentle motion. Spicules, thin, flame-like jets of gas, rise and fall around us like underwater kelp swaying in a cosmic ocean. These structures are immense by earthly standards, stretching thousands of miles, yet they move with the grace of dancers, bending and swaying to rhythms set by magnetic fields and pressure waves. Like whispers in the night, these spicules carry material from the lower atmospheric layers upward, while other currents bring cooled gases back down. We drift among them, feeling their gentle turbulence as they create the chromosphere's characteristic texture. The spicules glow with their own internal light, adding moving brush strokes to the already beautiful canvas of colored atmosphere. In the quiet space between spicules, we encounter regions of different density and temperature. Some areas are slightly warmer, glowing with more intense colors, while others are cooler and more subdued. This creates a three-dimensional tapestry of light and shadow that we navigate like explorers. In a gentle maze of stellar atmosphere, the magnetic fields here are stronger and more organized than in the solar wind regions we left behind. We can sense their presence like invisible highways running through the colored gas, guiding the movement of charged particles and shaping the behavior of the atmospheric layers. These magnetic structures create channels and barriers that influence how the chromosphere's colors mix and blend. Gently, we discover that our journey through the chromosphere is taking us through regions of different chemical composition. Areas rich in hydrogen glow with deeper pinks and reds, while regions with more helium shine with golden and yellow hues. Traces of heavier elements create subtle accents, touches of green from iron, hints of blue from other metals, all blending together in a stellar watercolor painting. Like whispers in the night, the atoms around us share the stories of their excitation. When energy from below reaches them, electrons jump to higher orbits with quiet precision. When they fall back down, they release photons of specific colors, each one a tiny contribution to the chromosphere's gentle glow. We witness this process happening millions of times each second, yet it feels as peaceful as watching snowfall. The pressure waves that travel through the chromosphere create subtle music that we feel rather than hear. These acoustic oscillations carry energy from the sun's interior, and as they pass through the atmospheric layers, they create gentle compressions and rarefactions that make the colors around us pulse and breathe with stellar rhythm. In the quiet space of these sound waves, we discover that the chromosphere acts like a cosmic instrument, with different regions resonating at different frequencies. The hydrogen-rich areas sing in one register, the helium zones harmonize in another, and the traces of heavier elements provide subtle overtones that enrich the overall symphony. As we drift deeper into the chromosphere, the colors around us continue to intensify and evolve. The soft pink of hydrogen becomes more pronounced, the golden glow of helium grows richer, and new colors begin to emerge as we encounter atoms and ions. that exist only in these unique stellar conditions. Each new hue is a gentle surprise, a cosmic gift that reveals another aspect of stellar atmosphere. Gently, we discover that the chromosphere's colors are not static paintings but living, breathing artworks that change with the sun's activity. Magnetic field fluctuations cause some regions to brighten or dim, while pressure waves create traveling patterns of color that ripple through the atmospheric layers, like auroras in slow motion. Like whispers in the night, the chromosphere tells us about the delicate balance between energy input from below and energy radiation into space. This layer acts as a gentle filter, absorbing certain wavelengths of light while allowing others to pass through. We are traveling through a cosmic stained glass window, experiencing light and color in ways that exist nowhere else in the universe. The boundary between the chromosphere and the regions below begins to make itself known. Through subtle changes in the light around us, the colors grow deeper and more saturated. The atmospheric density increases with gentle persistence, and we can sense that we are approaching the next phase of our stellar journey. The chromosphere has been our introduction to the sun's atmospheric personality, showing us how stellar gases can create beauty even in the harshest environments. In the quiet space of this transition, we take a moment to appreciate what the chromosphere has taught us. We have learned that stellar atmospheres are not simple things, but complex, layered environments where temperature, pressure, and composition create zones of unique beauty. We have seen how magnetic fields sculpt and guide atmospheric behavior, how atoms contribute their individual voices to create collective harmonies of light. The spicules around us continue their gentle dance, and we realize that we have been witnessing the sun's breath made visible. These atmospheric currents are how our star exchanges material and energy between its different layers. A slow, patient circulation that has continued for billions of years and will continue for billions more. Gently, we discover that our time in the chromosphere has prepared us for the deeper layers ahead. The colors we have experienced here are just the beginning of the sun's artistic expression. The pressure changes we have felt are gentle introductions to the more intense conditions that await us. The magnetic fields we have sensed will become stronger and more influential as we continue our journey inward. Like whispers in the night, the chromosphere's colors begin to fade as we prepare to leave this layer behind. The soft pinks and golds that surrounded us gradually give way to new hues, new intensities, new forms of stellar beauty. We carry with us the peaceful memory of swimming through colored light, of witnessing atoms paint with photons, of experiencing the gentle artistry of stellar atmosphere. As our journey through the chromosphere reaches its gentle conclusion, we feel grateful for this introduction to the sun's atmospheric complexity. We have learned that even in the extreme environment of a star, beauty and harmony can flourish. The colors that surrounded us were not harsh or violent, but gentle and welcoming, inviting us to continue deeper into the stellar mystery with confidence and wonder. Now we float toward the photosphere, the sun's visible surface where light itself is born. In the quiet space of our continued descent, we begin to sense the approach of something truly special. The chromosphere's colored whispers gradually fade behind us, replaced by a new kind of illumination that seems to come from everywhere at once. We are approaching the photosphere, the sun's visible surface, the layer that creates the golden light we see from Earth. Here, in this gentle boundary between the star's interior and its atmosphere, we will witness the birth of sunlight itself. Gently, we discover that the photosphere is not a solid surface like the ground beneath our feet on Earth, but rather a region where the sun's gases become thick enough to become opaque. Like whispers in the night, photons that have traveled for thousands of years through the stellar interior finally find their freedom here, escaping into space to carry the sun's warmth to distant worlds. The first thing we notice is the incredible gentleness of the light around us. Despite being at the source of all the illumination that reaches our planet, the photosphere embraces us with a glow that feels nurturing rather than harsh. The temperature here is surprisingly moderate, warm enough to create the brilliant light we observe, yet cool enough for our journey to continue in comfort. In the quiet space of the photosphere's upper reaches, we observe the surface texture that gives this layer its character. The entire visible surface is covered in a pattern called granulation, a cellular structure that looks like a vast, gentle bubbling. Each granule is a convection cell, a place where hot gases rise from below, cool slightly, and then sink back down in a process as natural and rhythmic as breathing. Like whispers in the night, these granules tell us the story of the sun's interior energy fighting its way to the surface. Each cell is thousands of miles across, yet from our cosmic perspective, they create a texture as fine and beautiful as hammered metal. The centers of the granules glow slightly brighter where the hottest gases emerge, while the boundaries appear darker where the cooled material descends back into the stellar depths. Gently, we discover that this granulation is in constant, peaceful motion. The pattern shifts and changes like the surface of slowly boiling honey, with granules forming, evolving, and dissolving in a dance that has continued for billions of years. We drift above this textured surface, watching the gentle circulation that brings energy from the sun's core to the surface, where it can finally escape as light. The photons around us are like newly freed prisoners, having spent millennia working their way up through the dense stellar interior. Now, in the photosphere's embrace, they can finally travel in straight lines. Racing away from the sun at the speed of light, we watch in peaceful wonder as these particles of light begin their journeys to illuminate planets, warm distant worlds, and eventually reach the eyes of creatures who will look up at their star with curiosity and awe. In the quiet space between granules, we encounter areas of different magnetic field strength, where the fields are particularly intense. They create features called sunspots, regions that appear darker, because the magnetic forces reduce the convection that normally brings hot material to the surface. These sunspots are not flaws or scars, but rather beauty marks that reveal the sun's invisible magnetic personality. Like whispers in the night, the sunspots tell us stories of magnetic field lines that have become twisted and concentrated through the sun's rotation and internal motions. These dark regions are still incredibly hot by earthly standards, but they appear darker in contrast to the even brighter areas around them. They create patterns across the photosphere's surface that change over days and months, giving the sun a slowly evolving face. Gently, we discover that sunspots often come in pairs or groups, connected by invisible magnetic field lines that arch above the photosphere's surface. These magnetic loops create highways for charged particles, and can sometimes release their stored energy in gentle flares that send additional light and particles streaming into space. Even these more energetic events have a cosmic grace, like the sun clearing its throat or stretching after a long rest. The light that surrounds us in the photosphere contains the full spectrum of colors that combine to create the white light we see from Earth. But here, at the source, we can sense the individual contributions of different atoms and ions as they emit their characteristic wavelengths. Hydrogen adds its deep red notes, helium contributes yellow and orange hues, and traces of heavier elements provide subtle accent colors throughout the spectrum. In the quiet space of the photosphere's gentle glow, we observe how the sun's rotation creates subtle patterns in the granulation and magnetic features. The equatorial regions spin faster than the polar areas, creating a differential rotation that slowly twists and tangles the magnetic field lines over time. This process gives the sun its magnetic personality and creates the cycles of activity that vary over many years. Like whispers in the night, the photosphere's edges reveal the sun's limb darkening, a subtle effect, where the solar disk appears slightly dimmer at its edges when viewed from a distance. This happens because we're looking at shallower, cooler layers of the atmosphere near the edges, while the center of the disk allows us to see deeper into the warmer, brighter regions. It's a gentle reminder that the sun is a three-dimensional object with depth and structure. The convection cells beneath us create subtle sound waves that travel through the photosphere, like ripples on a pond. These solar oscillations make the sun ring like a bell, though at frequencies far too low for human ears to detect. The photosphere rises and falls by tiny amounts as these acoustic waves pass through, creating a gentle breathing motion that helps astronomers understand the sun's internal structure. Gently, we discover that the photosphere acts as a window into the sun's interior conditions. The light that emerges here carries information about the temperature, pressure, and composition of the layers below. By analyzing this light with careful instruments, scientists can read the sun's vital signs and understand the nuclear processes that power our star. In the photosphere's embrace, we feel the steady pressure of radiation not as a harsh force, but as a gentle, constant presence that reminds us of the incredible energy production happening in the sun's core. This radiation pressure helps support the sun against its own gravity, creating a delicate balance that has kept our star stable for billions of years, and will continue to do so for billions more. Like whispers in the night, the photosphere tells us about the sun's chemical composition. While hydrogen and helium dominate, we can detect traces of nearly every element in the periodic table. These heavier elements, created in other stars and scattered through space by stellar explosions, have been incorporated into our sun's structure. They represent the cosmic recycling that connects our star to the generations of stars that came before it. The temperature in the photosphere follows a gentle gradient, cooling gradually as we move away from the stellar interior. This temperature structure determines which atoms can exist in which states of ionization, creating layers where different elements contribute most strongly to the spectrum. We travel through this temperature landscape like hikers moving through climate zones. On a cosmic mountain, in the quiet space of the photosphere's depths, we observe how convection shapes not just the granulation pattern, but the entire structure of this layer. Hot gases rise in columns that spread out when they reach the surface, then cool and sink back down in a circulation pattern that efficiently transports energy from the interior to the surface. This convection is so gentle that it creates beauty rather than violence. Gently, we discover that the photosphere is where many of the absorption lines in the sun's spectrum are created. As light tries to escape from deeper, hotter layers, atoms in the photosphere absorb specific wavelengths, creating dark lines in the spectrum that act like fingerprints, identifying the elements present and their physical conditions. These absorption features are letters in the alphabet that scientists use to read the sun's story. Like whispers in the night, the photosphere reveals the sun's magnetic field through subtle effects on the light it produces. In regions of strong magnetic field, spectral lines split into multiple components through the Zeeman effect, allowing us to map the invisible magnetic landscape of the solar surface. These magnetic signatures show us that the sun's surface is alive with invisible forces that shape its behavior. The edge of each granule creates a subtle landscape of hills and valleys in the photosphere's surface. While these elevation changes are tiny compared to the sun's enormous size, they create variations in the local temperature and density that affect how light escapes. We drift over this gentle topography, feeling the subtle changes in the atmospheric thickness and composition. In the photosphere's patient embrace, we witness the final stage of photons' long journey from the sun's core. After spending thousands of years bouncing randomly through the dense interior, these particles of light finally achieve escape velocity and stream away into space. Some will warm planets, some will be absorbed by dust clouds, and some will travel for millions of years before encountering anything at all. Gently, we discover that the photosphere's activity level varies with the sun's magnetic cycle. During periods of high activity, more sunspots appear, the granulation pattern becomes more vigorous, and the surface brightens slightly as magnetic energy adds to the thermal energy emerging from below. During quiet periods, the surface becomes more uniform and peaceful, though still maintaining its essential character. Like whispers in the night, the photosphere prepares us for the next phase of our journey by gradually increasing the density and temperature of our surroundings. The gentle glow that characterizes this layer begins to intensify, and we can sense that we are approaching regions where the sun's internal energy transport mechanisms change from radiation to convection. As our time in the photosphere draws to its peaceful close, we feel grateful for witnessing the birthplace of sunlight. This layer has shown us how stellar energy finally achieves its freedom, how magnetic fields create surface beauty, and how convection paints the sun's face with ever-changing patterns. The photosphere has been our last glimpse of the sun's external personality. Before we dive into the more mysterious interior realms, in the quiet space of transition, we carry with us the memory of the photosphere's gentle glow, the sight of granules forming and dissolving in their eternal dance, and the knowledge that we have witnessed the surface when nuclear fire becomes visible light. This layer has taught us that even at the source of tremendous energy, there can be beauty, pattern, and a peaceful order that speaks to the underlying harmony of stellar physics. As our journey continues, we sink gently beneath the photosphere into the convection zone. In the quiet space below the photosphere's visible glow, we discover a realm unlike anything we have encountered in our stellar journey. Here begins the convection zone, a vast region that extends nearly a third of the way to the sun's center. Like whispers in the night, the gases around us begin to move with purpose and direction, carrying energy upward through bulk motion rather than through the simple passage of light. Gently, we discover that we are now passengers in an enormous circulation system. The convection zone operates like a cosmic engine, with hot material rising from the depths while cooler material sinks back down in a continuous, patient cycle. We feel ourselves caught up in one of these rising currents, lifted by gas that has been heated far below and is now making its leisurely journey toward the surface. The temperature around us begins to increase with depth, but so gradually that we barely notice the change. Like whispers in the night, the stellar material surrounding us grows denser and hotter as we sink deeper. Yet the convection currents carry us with such gentle precision that our journey remains comfortable and peaceful. We are riding in nature's most magnificent elevator, powered by the fundamental forces of heat and buoyancy. In the quiet space of the convection zone's upper layers, we observe how the rising and sinking motions create a three-dimensional network of currents. Some columns of gas rise quickly and directly, while others follow more leisurely, winding paths. Some regions sink with quiet purpose, while others seem to hover in gentle balance. This creates a living, breathing structure within the sun that is constantly moving yet fundamentally stable. Like whispers in the night, the convective currents tell us stories of energy transport that is far more efficient than radiation alone. In the dense layers below, light moves so slowly through the stellar material that it would take hundreds of thousands of years for energy to reach the surface. But here, in the convection zone, bulk motion carries that energy upward in just a few weeks, creating a cosmic shortcut that keeps our star burning brightly. Gently, we discover that the convection zone is organized into cells of different sizes, nested within each other like cosmic Russian dolls. The largest cells stretch across enormous distances and complete their circulation cycles. Over months or years, medium-sized cells create the granulation we observed at the photosphere. Smaller cells create fine-scale turbulence that mixes and stirs the stellar material. With gentle thoroughness, the magnetic field lines in the convection zone are far more complex than anything we encountered. In the solar atmosphere, the moving gas carries these field lines along, stretching and twisting them into intricate patterns. In the quiet space of these magnetic tangles, we feel the slow build-up of magnetic energy that will eventually emerge at the surface to create sunspots and solar flares. In deeper layers of the convection zone, we encounter a phenomenon that exists nowhere else in the solar system: differential rotation. That varies with depth. The stellar material at different layers rotates at slightly different speeds, creating a gentle shearing motion that helps generate the sun's magnetic field. Like whispers in the night, this rotation whispers to us about the dynamo process that gives our star its magnetic personality. Gently, we discover that the convection zone acts as a giant mixing bowl stirring elements that were created in the sun's core billions of years ago with material that has remained near the surface since the star's formation. This slow, patient mixing process ensures that the sun's composition remains relatively uniform throughout the convective region, creating a cosmic homogeneity that has important implications for stellar evolution. Like whispers in the night, the convective motions create sound waves that propagate throughout the sun's structure. These acoustic waves carry information about conditions in different layers, creating the solar oscillations that make the sun ring like a cosmic bell. We feel these sound waves passing through us as gentle pressure variations that reveal the sun's internal architecture. The deeper we sink into the convection zone, the more we appreciate the incredible scale of the motions around us. Individual convection cells can be larger than entire planets, yet they move with fluid grace through the stellar interior. The hot rising material glows with the energy it has absorbed from below, while the cooler sinking material carries away the heat it has delivered to upper layers. In the quiet space of the convection zone's middle layers, we observe how the stellar material's properties change with depth and temperature. The gas becomes more ionized as we descend, with atoms losing more of their electrons to the increasingly energetic environment. Yet this ionization happens gradually and peacefully, each electron finding its appropriate energy level in the thermal equilibrium of its surroundings. Gently, we discover that the convection zone contains the Sun's weather system's vast patterns of circulat, iron that persist for months or years before slowly evolving into new configurations. These stellar weather patterns influence everything from the surface granulation to the magnetic field generation, creating long-term variability in the Sun's behavior that affects the entire solar system. Like whispers in the night, the convective flows carry with them the chemical signatures of nuclear fusion from the core. Although the fusion reactions happen far below us, the products of those reactions, helium nuclei created from hydrogen, slowly work their way upward. Through the convection zone's mixing processes, we are traveling through a region where the Sun's nuclear past gradually becomes its observable present. The turbulence in the convection zone is unlike earthly turbulence. It is gentle, organized, and purposeful. Rather than creating chaos, the convective motions form ordered patterns that efficiently transport energy, while maintaining the Sun's overall stability. We drift through this organized turbulence like leaves caught in a thermal updraft, carried smoothly upward and downward by forces that are both powerful and benevolent. In the convection zone's depths, we encounter temperature and pressure conditions that would be extreme by earthly standards. Yet the gradual nature of our descent makes these conditions feel natural and comfortable. The stellar material around us has the consistency of very dense gas, far thicker than air but still flowing freely in response to temperature and pressure differences. Gently, we discover that the convection zone's efficiency varies with depth and local conditions. In some regions, the temperature gradient is steep enough to drive vigorous convection, while in others, the energy transport is more leisurely and gentle. These variations create a complex three-dimensional structure that gives the Sun its unique personality and behavior patterns. Like whispers in the night, the convection zone reveals how stellar structure is determined by the delicate balance between gravity trying to compress the star and thermal pressure trying to expand it. The convective motions help maintain this balance by efficiently transporting energy outward, preventing the Sun from either collapsing under its own weight or expanding uncontrollably. The magnetic field generation in the convection zone operates through processes that are both complex and beautiful. The differential rotation and convective motions work together to stretch, twist, and amplify magnetic field lines, creating the dynamo action that gives the Sun its magnetic field. We feel ourselves becoming part of this dynamo process as we move with the convective flows. In the quiet space of the convection zone's lower reaches, we begin to sense the approach of a different regime. The convective motions around us gradually slow and diminish as we approach the boundary with the radiative zone below. This transition is not abrupt but gentle, like moving from a flowing river into a calm lake. Gently, we discover that the convection zone's base is determined by the stellar material's opacity, its ability to absorb and scatter light. Below this boundary, the material becomes transparent enough for radiation to once again become the dominant method of energy transport. Above this boundary, the material is opaque enough that convection becomes necessary to carry energy efficiently toward the surface. Like whispers in the night, the convection zone prepares us for the next phase of our journey by gradually changing the character of our surroundings. The bulk motions that have carried us so far begin to fade, replaced by the more subtle processes of radiative energy transport. The temperature and density continue to increase, but the nature of energy flow shifts from the mechanical to the electromagnetic. As our passage through the convection zone nears its peaceful conclusion, we reflect on what this region has taught us about stellar structure and energy transport. We have witnessed how stars solve the problem of moving energy from their cores to their surfaces, how magnetic fields are generated and maintained, and how the Sun's internal motions influence everything from surface granulation to long-term activity cycles. The convection zone has shown us that stellar interiors are not static, uniform spheres, but dynamic, structured environments where complex processes work together to maintain stellar stability. The convective motions we have experienced are part of a system that has operated smoothly for billions of years, demonstrating the elegant efficiency of stellar physics. In the quiet space of transition toward the radiative zone, we carry with us the memory of riding the sun's internal currents, of witnessing the dynamo processes that create magnetic fields, and of experiencing the patient efficiency with which convection transports energy. Through stellar interiors, the convection zone has been our introduction to the sun's hidden mechanical personality, the realm where thermal energy becomes organized motion before finally emerging as the light that illuminates our world. Let's drift into the radiative zone, where light begins its patient journey through stellar depths. In the quiet space below the convection zone's gentle currents, we enter a realm of extraordinary patience and subtle beauty. Here begins the radiative zone, a vast sphere that extends from about 1/3 of the sun's radius down to nearly its core. Like whispers in the night, this region operates by entirely different principles than the mechanical motions we have left behind. Here, energy moves not through bulk motion, but through the ancient dance of photons and matter. Gently, we discover that the radiative zone earned its name from the way energy travels through it purely by radiation. Photons created in the nuclear fires of the core begin their incredibly patient journey outward, not in straight lines as they do in space, but in a random walk that resembles the wandering of a lost traveler. Each photon takes step after tiny step, being absorbed and re-emitted countless times as it slowly works its way toward the surface. The stellar material around us is so dense that photons can travel only microscopic distances before being absorbed by an atom or electron. Like whispers in the night, each absorption is followed by a ray emission in a random direction, creating a cosmic pinball game where light bounces endlessly through the stellar interior. What would be a journey of a few seconds in empty space becomes an odyssey of hundreds of thousands of years. In the quiet space of the radiative zone's upper layers, we observe how the stellar material's properties create the perfect conditions for this patient energy transport. The gas is dense enough to absorb photons efficiently, yet not so dense that convection becomes necessary. The temperature is high enough to keep atoms ionized and active, yet not so high that radiation pressure overwhelms the delicate balance of stellar structure. Like whispers in the night, the photons around us carry stories of their origins in the nuclear furnace below. Each one began as a high-energy gamma ray created by fusion reactions, but through countless absorption and ray emission events, these energetic photons have been gradually degraded into lower energy forms. By the time they complete their journey through the radiative zone, they will have become the gentle visible light and infrared radiation that warm our world. Gently, we discover that the radiative zone is remarkably stable and uniform compared to the dynamic convection zone above. The stellar material here moves very little, maintaining its position and density for millions of years at a time. This stability creates a cosmic library, where the sun's history is preserved in the layered structure of temperature, density, and composition. The random walk of photons through the radiative zone follows mathematical principles that are both complex and beautiful. In the quiet space of this stellar interior, we can imagine each photon as a cosmic wanderer, taking millions of tiny steps in random directions. Some steps lead toward the surface, some toward the core, some sideways through the stellar sphere. Only the statistical tendency for outward motion ensures that energy eventually escapes. In the deeper layers of the radiative zone, we encounter temperature and pressure conditions that create perfect plasma, a state of matter, where electrons and atomic nuclei float freely, unbound by normal chemical forces. Like whispers in the night, this plasma tells us about matter under conditions that can only exist in stellar interiors, where the normal rules of chemistry and atomic structure are suspended in favor of simpler, more fundamental physics. Gently, we discover that the radiative zone acts as a cosmic thermostat, regulating the sun's energy output through the opacity of the stellar material. When the core becomes hotter and produces more energy, the increased radiation pressure slightly expands the radiative zone, making it more transparent and allowing energy to escape more quickly. This negative feedback mechanism has kept the sun's brightness remarkably stable throughout its long lifetime. Like whispers in the night, The atomic nuclei in the radiative zone reveal the Sun's chemical heritage. Most are hydrogen nuclei, simple protons that have existed since the universe's early moments. Others are helium nuclei created by fusion in the core or inherited from the Sun's formation. Traces of heavier elements tell stories of previous generations of stars that lived, died, and scattered their nuclear ashes into the interstellar medium. The pressure in the radiative zone comes not just from the weight of overlying material, but also from radiation itself. Photons exert pressure when they are absorbed or scattered, and in the dense stellar interior. This radiation pressure becomes a significant force. In the quiet space of the radiative zone, we feel this gentle but persistent outward push that helps support the Sun against gravitational collapse. In the radiative zone's patient embrace, we witness how stellar structure is determined by the fundamental equations of physics. The temperature and density at each point are set by the requirements of hydrostatic equilibrium, the balance between gravity pulling inward and pressure pushing outward. This balance creates a smooth, stable structure that has persisted for billions of years. Gently, we discover that the radiative zone's opacity, its ability to absorb photons, varies with temperature, density, and composition in ways that fine-tune the Sun's behavior. In regions where the material becomes more opaque, photons take longer to escape, causing energy to back up and temperatures to rise. In more transparent regions, energy flows more freely, creating a self-regulating system of remarkable precision. Like whispers in the night, the electrons in the radiative zone participate in a cosmic dance of absorption and emission. Free electrons scatter photons through Compton scattering, while bound electrons in atoms absorb and re-emit photons at specific wavelengths. This interaction between matter and radiation creates the fundamental mechanism by which energy slowly percolates outward through the stellar interior. The time scale of energy transport through the radiative zone is almost incomprehensible. By human standards, a photon created in today's core fusion reactions will not emerge from the Sun's surface for hundreds of thousands of years. In the quiet space of the radiative zone, we are surrounded by energy that was created during the age of early human civilization, only now beginning its final journey to the surface. In the deeper reaches of the radiative zone, we observe how the stellar material's equation of state, the relationship between pressure, density, and temperature, follows the laws of plasma physics. The material behaves as an ideal gas in many respects, but with corrections for radiation pressure and the effects of ionization. This creates a stellar interior that is both predictable and subtly complex. Gently, we discover that the radiative zone preserves evidence of the Sun's evolutionary history in its structure. The composition gradients created during the star's formation and early evolution are still visible in the distribution of elements throughout this region. Unlike the well-mixed convection zone above, the radiative zone maintains a chemical memory of the Sun's past. Like whispers in the night, neutrinos created by nuclear fusion in the core pass through the radiative zone, almost without interaction. These ghostly particles travel at nearly the speed of light, completing in seconds the same journey that takes photons hundreds of thousands of years. The radiative zone is transparent to neutrinos, allowing them to carry real-time information about the core's fusion processes directly to detectors on Earth. The temperature gradient in the radiative zone is carefully tuned by the stellar material's properties. In the quiet space of this temperature structure, energy flows outward at just the right rate to maintain stellar equilibrium. If the gradient were steeper, convection would begin. If it were shallower, energy transport would be too slow, and the stellar interior would overheat. In the radiative zone's depths, we encounter the effects of gravitational settling, the slow process by which heavier elements gradually sink toward the center while lighter elements rise. This process operates over millions of years, slowly changing the Sun's internal composition and structure. Like whispers in the night, this settling process tells us about the Sun's slow aging and evolution. Gently, we discover that the radiative zone's stability makes it an excellent cosmic laboratory for studying matter under extreme conditions. The plasma here exists in thermal equilibrium with temperatures, densities, and ionization states determined by fundamental physics rather than dynamic processes. This creates conditions that exist nowhere else in the universe and nowhere in earthly laboratories. The magnetic field in the radiative zone is much weaker and more organized than in the convection zone above, without bulk motions to stretch and tangle field lines. The magnetic structure here is primarily determined by the Sun's original magnetic field, slowly evolving through diffusion and reconnection processes. In the quiet space of this weak magnetic environment, we feel the underlying simplicity of the stellar magnetic structure. Like whispers in the night, the radiative zone reveals how stars solve the fundamental problem of energy transport. In dense matter, the random walk of photons, while incredibly slow, is ultimately reliable and stable. This patient process has powered the Sun for billions of years, and will continue to do so for billions more, demonstrating the elegant efficiency of radiative energy transport in stellar interiors. As we prepare to continue our journey deeper into the Sun, we reflect on the lessons of the radiative zone. This region has taught us about patience on cosmic timescales, about the random walk of energy through matter, and about the delicate balance of forces that maintains stellar stability. The radiative zone represents the Sun's memory, a stable, slowly changing region that preserves the star's history, while patiently processing its energy output. In the quiet space of transition toward the core, we carry with us an appreciation for the subtle processes that make stars possible. The radiative zone has shown us that stellar physics operates through patient, statistical processes that achieve remarkable precision, through the accumulation of countless small interactions. Here, in this realm of wandering photons and plasma equilibrium, we have witnessed the mechanism that transforms nuclear fire into gentle starlight. Gently, we discover that our journey through the radiative zone has prepared us for the ultimate destination, the Sun's core, where the energy we have followed through its patient outward journey actually begins. The increasing temperature and density around us signal our approach to the nuclear furnace that powers our star, the cosmic forge where hydrogen becomes helium and mass becomes energy in the most fundamental transformation in the universe. Now we float toward the Sun's core, where the fundamental forces of creation await us. In the quiet space of our deepest descent, we begin to sense the approach of something truly extraordinary. The radiative zone's patient photon wandering gradually gives way to conditions unlike anything else in our solar system. We are approaching the Sun's core, a sphere roughly the size of Jupiter, but containing a quarter of the Sun's total mass. Like whispers in the night, the very atoms around us begin to tremble with the energy of nuclear transformation. Gently, we discover that the transition toward the core is marked by subtle but profound changes in our environment. The temperature, which has been rising steadily throughout our journey, now approaches 15 million degrees. The pressure becomes millions of times greater than Earth's atmospheric pressure. Yet these extreme conditions manifest themselves not as violence or chaos, but as a kind of cosmic intensity that speaks to the fundamental forces of creation. The stellar material around us has now reached a state of perfect plasma equilibrium. Like whispers in the night, the atomic nuclei and electrons move in patterns determined by temperature, pressure, and electromagnetic forces. There are no molecules here, no chemical bonds as we understand them on Earth. Instead, we find ourselves in a realm where matter exists in its most fundamental form, bare nuclei and free electrons dancing to the rhythm of thermal motion. In the quiet space approaching the core's boundary, we observe how the extreme conditions create effects that exist nowhere else in nature. The pressure is so intense that it overcomes the natural electrical repulsion between atomic nuclei, forcing them close enough together for nuclear forces to take effect. The temperature is so high that particles move with energies that make nuclear fusion not just possible, but inevitable. Like whispers in the night, the hydrogen nuclei around us, simple protons that have existed since the universe's infancy, begin to reveal their potential for transformation. Under these extreme conditions, they move fast enough and approach close enough to overcome their electrical repulsion and fuse together, creating heavier nuclei and releasing the energy that has powered the Sun for 5 billion years. Gently, we discover that the approach to the core is governed by the inexorable logic of stellar physics. Gravity has compressed the stellar material to the point When nuclear fusion becomes self-sustaining, the energy released by fusion creates the pressure that supports the Sun against further gravitational collapse. This delicate balance between nuclear fire and gravitational compression creates the stable, long-lived structure we call a main sequence star. The density of the stellar material around us has reached incredible levels, about 10 times denser than lead, yet still maintaining the properties of a gas because of the extreme temperature. In the quiet space of this dense plasma, we witness matter in a state that challenges our earthly understanding of how substances behave. The material flows like a fluid while being denser than the heaviest metals. In the core's outer regions, we encounter the first signs of active nuclear fusion. Like whispers in the night, protons begin their patient dance of collision and combination. The fusion rate is incredibly sensitive to temperature. Even small changes in the core S temperature create large changes in the energy production rate. This sensitivity helps regulate the Sun's energy output and maintain its long-term stability. Gently, we discover that the nuclear fusion processes about to unfold around us operate through quantum mechanical effects that allow reactions to occur even when classical physics says they should be impossible. The quantum tunneling effect enables some protons to overcome their electrical repulsion even when they don't have quite enough energy to do so classically. This quantum assistance makes stellar fusion possible at only 15 million degrees rather than requiring much higher temperatures. Like whispers in the night, the core reveals its chemical composition, about 60% hydrogen and 40% helium, with trace amounts of heavier elements. The helium has been steadily accumulating as fusion converts hydrogen into helium nuclei. Over the Sun's 5 billion-year lifetime, the core's composition has been slowly changing, creating a region that is fundamentally different from the outer layers we have traveled through. The extreme conditions approaching the core create effects on the stellar material S opacity that help regulate fusion rates. In the quiet space of these density and temperature extremes, the plasma becomes more transparent to certain types of radiation, while becoming more opaque to others. This creates natural feedback mechanisms that help stabilize the fusion process against runaway reactions. In the core's gravitational embrace, we feel the full weight of the Sun's mass pressing inward. The gravitational field here is nearly 30 times stronger than Earth's gravity. Yet this tremendous inward pull is balanced by the outward pressure of radiation and hot plasma, creating an equilibrium that has persisted for billions of years and will continue for billions more. Gently, we discover that the core S energy production is remarkably concentrated, about half of the Sun's total power output comes from just the innermost 25% of its radius. This concentration of energy production in a relatively small volume creates the intense conditions necessary for fusion while allowing the outer layers to transport energy away efficiently. Like whispers in the night, the core's rotation rate tells us about the Sun's internal structure and evolution. The core rotates faster than the outer layers, preserving angular momentum from the Sun's formation and early evolution. This differential rotation contributes to the magnetic dynamo processes that generate the Sun's magnetic field, connecting the core's physics to the surface phenomena we observed earlier in our journey. The approach to the core brings us into contact with neutrinos, ghostly particles, created by nuclear fusion that pass through matter almost without interaction. In the quiet space of the core's outer regions, we feel these neutrinos streaming past us at nearly the speed of light, carrying real-time information about the fusion processes directly from their point of creation to detectors throughout the solar system. In the core's intense environment, we observe how the fundamental forces of nature work together to create stellar stability. The strong nuclear force enables fusion between protons. The electromagnetic force creates the pressure that supports the star against gravity. The weak nuclear force governs some of the fusion reactions and creates the neutrinos that carry energy away from reaction sites. Gently, we discover that the core's physics operates on multiple time scales simultaneously. Nuclear reactions occur in tiny fractions of a second. Energy diffusion through the dense plasma takes minutes to hours. The core's thermal response to changes operates over thousands of years. The core's structural evolution occurs over billions of years. All these processes work together to create the Sun's remarkable stability. Like whispers in the night, the core reveals the quantum mechanical nature of stellar fusion. The protons around us exist in quantum states that allow them to tunnel through energy barriers, to exist in multiple states simultaneously until measurements collapse their wave functions, and to follow probability distributions rather than deterministic paths. Stellar fusion is fundamentally a quantum mechanical process operating on a cosmic scale. The temperature structure approaching the core follows the requirements of hydrostatic equilibrium, but with the added complexity of energy generation. In the quiet space of the core's outer layers, we observe how the temperature gradient adjusts itself to transport the energy produced by fusion, while maintaining pressure balance against gravity. This creates a temperature profile that is precisely tuned to stellar physics. In the core's depths, we encounter matter in states that provide laboratories for fundamental physics. The dense plasma creates conditions for studying equation of state physics, neutrino interactions, nuclear reaction rates, and quantum mechanical effects under extreme conditions. The core is nature's most accessible example of matter under conditions that cannot be reproduced. In earthly laboratories, gently, we discover that the core's energy production rate varies in space and time in ways that create natural regulation mechanisms. Regions that become slightly hotter produce energy at exponentially higher rates, which creates additional pressure that tends to cool them back down. This negative feedback helps prevent runaway fusion reactions and maintains the steady energy output that makes life possible on Earth. Like whispers in the night, the core's magnetic field reveals its connection to the dynamo processes operating in the outer layers. The core's field is primarily fossil, left over from the Sun's formation, but it influences and is influenced by the magnetic fields generated by differential rotation and convection in the overlying layers. This creates a complex magnetic ecosystem that extends throughout the solar interior. The approach to the core brings us to regions where the stellar material's properties are determined by the physics of degenerate matter, while not fully degenerate like the material in white dwarf stars. The core's plasma shows signs of quantum mechanical effects that become important at high densities. These effects influence the pressure, energy transport, and nuclear reaction rates in subtle but important ways. In the quiet space of the core's boundary region, we observe how stellar evolution has left its mark on the Sun's internal structure. The accumulation of helium from billions of years of fusion has changed the core's composition and properties. The slow diffusion of heavy elements has created subtle composition gradients. These evolutionary changes operate so slowly that they are imperceptible on human timescales, yet they determine the Sun's long-term destiny. Gently, we discover that our approach to the core has brought us to the source of all the energy we have followed throughout our stellar journey. The nuclear reactions about to unfold around us create the gamma rays that begin the random walk through the radiative zone. They produce the energy that drives convection in the outer layers. They generate the heat that creates the photosphere's glow and powers the solar wind that we encountered at the beginning of our journey. Like whispers in the night, the core prepares us for the ultimate revelation of stellar physics. The nuclear furnace where hydrogen becomes helium, where mass becomes energy, where the fundamental forces of nature collaborate to power the star that makes life possible in our solar system. We stand at the threshold of creation itself, about to witness the cosmic processes that transform the simplest atoms into the energy that illuminates and warms our world. As we prepare to enter the core proper, we reflect on the incredible journey that has brought us to this point. We have traveled through the Sun's atmosphere, its convection zone, its radiative zone, and now approach the nuclear furnace at its heart. Each layer has revealed new aspects of stellar physics, new forms of beauty, and new demonstrations of the elegant complexity that makes stars possible. The core awaits us as the source and explanation of everything we have experienced. On our journey through the Sun, as our journey continues, we enter the very heart of creation, the Sun's core. In the quiet space of the Sun's innermost realm, we find ourselves at the center of everything, literally and figuratively. Here, in a sphere smaller than our journey has been long, we witness the nuclear furnace that powers not just our star, but ultimately all life in our solar system. Like whispers in the night, the very fabric of matter transforms around us. as hydrogen nuclei shed their individual identities to become something greater than the sum of their parts. Gently, we discover that we have entered a realm where the fundamental forces of nature work in perfect harmony. The temperature here reaches 15 million degrees Celsius, hot enough to strip atoms down to their bare essentials and provide the energy needed for nuclear fusion. The pressure crushes matter to densities over 10 times that of lead, yet the material still behaves as a gas because of the incredible thermal energy present. The nuclear processes unfolding around us operate through a chain of reactions, called the proton-proton chain. Like whispers in the night, this process begins with the most common nucleus in the universe, simple hydrogen nuclei, each consisting of a single proton. Under the extreme conditions of the core, these protons move fast enough to overcome their natural electrical repulsion and approach close enough for the strong nuclear force to bind them together. In the quiet space of nuclear transformation, we observe the first step of stellar nuclear synthesis. Two protons collide with such energy that one transforms into a neutron through the weak nuclear force, creating a deuterium nucleus while releasing a positron and a neutrino. This reaction is incredibly rare. A typical proton in the Sun's core waits billions of years before successfully fusing with another proton. Yet with trillions upon trillions of protons present, the reactions occur constantly around us. Like whispers in the night, the positrons created by fusion quickly find electrons and annihilate, converting their mass into pure energy according to Einstein's famous equation E=mc. These annihilation events contribute to the intense radiation field that fills the core, adding to the energy produced directly by nuclear binding. Every reaction creates a tiny flash of energy that will eventually, after hundreds of thousands of years, emerge as sunlight. Gently, we discover that the deuterium nuclei created in the first fusion step don't remain alone for long. The dense, hot conditions of the core ensure that each deuterium nucleus quickly encounters another proton and fuses with it to create helium-3, a light isotope of helium containing two protons and one neutron. This second step happens much more quickly than the first, typically within seconds of the deuterium nucleus's creation. The nuclear dance continues as helium-3 nuclei seek out partners for the final step of the proton-proton chain. In the quiet space of the core's fusion reactions, the helium-3 nuclei collide and fuse, creating a normal helium-4 nucleus while releasing two protons back into the stellar plasma. These recycled protons become available to begin the fusion chain anew, ensuring that the process can continue for billions of years. In this cosmic alchemy, we witness the most fundamental transformation in the universe, the conversion of mass into energy. Like whispers in the night, each completed proton-proton chain converts the hydrogen nuclei into one helium nucleus. But the helium weighs slightly less than the original hydrogen. That missing mass, less than 1% of the original, becomes energy, according to Einstein's mass-energy equivalence, providing the power that keeps our star shining. Gently, we discover that the core's fusion processes create different types of particles that tell the story of stellar nuclear synthesis. Gamma rays carry away most of the fusion energy, beginning their long random walk toward the surface. Neutrinos speed away at nearly the speed of light, passing through the entire sun in seconds and carrying information about core conditions directly to detectors on Earth and throughout the solar system. Like whispers in the night, the neutrinos reveal the real-time operation of the solar furnace. Unlike the light that takes hundreds of thousands of years to escape the sun, neutrinos created in fusion reactions stream away immediately, allowing scientists to observe the core's nuclear fires directly. These ghostly particles carry the news of fusion reactions happening at this very moment. In the sun's heart, the fusion rate in the core is exquisitely sensitive to temperature. Even a small change in core temperature creates a large change in energy production. In the quiet space of this nuclear furnace, this temperature sensitivity creates a natural thermostat that regulates the sun's energy output. If the core becomes hotter, fusion increases, creating more energy and pressure that tends to cool the core. If it becomes cooler, fusion decreases, allowing gravity to compress and heat the core back up. In the core's depths, we observe how the products of fusion gradually change the stellar composition. Over the Sun's 5 billion-year lifetime, fusion has converted about half of the core's original hydrogen into helium. This gradual accumulation of helium ash in the nuclear furnace slowly changes the core's properties and will eventually determine the Sun's evolutionary future when hydrogen becomes scarce. Gently, we discover that the core's nuclear processes operate at rates that seem both impossibly slow and incredibly fast. Individual protons wait billions of years to participate in fusion. Yet the core produces energy equivalent to billions of hydrogen bombs every second. This paradox illustrates the incredible scale of stellar interiors. Vast numbers of particles ensure that even rare processes happen continuously. Like whispers in the night, the core reveals traces of heavier elements that tell stories of cosmic history. While hydrogen and helium dominate, tiny amounts of carbon, nitrogen, oxygen, and other elements act as catalysts in alternative fusion chains, or simply bear witness to the Sun's formation from gas. Clouds enriched by previous generations of stars. These heavy elements represent the nuclear legacy of stars that lived and died before our Sun was born. The quantum mechanical nature of stellar fusion becomes apparent in the core's operation. In the quiet space of nuclear interactions, we observe how protons tunnel through energy barriers that classical physics says should be insurmountable. This quantum tunneling effect makes stellar fusion possible at only 15 million degrees, rather than the hundreds of millions of degrees that would be required classically. In the core's nuclear furnace, we witness how the fundamental constants of physics determine stellar behavior. The strength of the nuclear forces, the masses of protons and neutrons, the charge of the electron. All these values are perfectly tuned to make stable, long-lived stars possible. Small changes in any of these constants would create a universe where stars either burned out quickly or never ignited at all. Gently, we discover that the core's energy production creates a delicate balance with the overlying stellar layers. The nuclear fires produce just enough energy to support the Sun against gravitational collapse, but not so much that the star expands uncontrollably. This balance has persisted for billions of years and will continue until the core's hydrogen fuel begins to run low in the distant future. In the quiet space of this solar embrace, something gentle begins to unfold. Your physical form, which has traveled so peacefully through the Sun's layers, now discovers a secret transformation. Like whispers in the night, the very atoms that compose your being start to dance with the stellar matter around you. Feel how softly this change occurs. There is no sudden shift, no startling moment of alteration. Instead, observe how gradually your boundaries begin to blur, as if you were made of morning mist slowly merging with the dawn. The hydrogen and helium that surround you welcome your carbon, your oxygen, your nitrogen, all the quiet elements that have been your companions throughout your earthly journey. Gently, we discover that matter and energy are not separate things, but different faces of the same cosmic truth. Your being begins to glow with the same peaceful radiance that illuminates the solar depths. In the hidden heart of fusion, where nuclei drift together in their ancient dance, you sense your own essence joining this eternal rhythm. Watch peacefully as your consciousness expands beyond the familiar boundaries of skin and bone. Like a gentle river flowing into a calm ocean, your awareness merges with the vast intelligence of the star itself. You can feel the Sun's quiet wisdom, accumulated over billions of years of steady burning, of faithful service to the planets that orbit in its gentle light. In the quiet space of transformation, time moves differently. What might seem like moments stretch into peaceful eternities, and what feels like eons pass in the soft space of a single breath. You drift through layers of understanding, each one more gentle and encompassing than the last. The process is beautiful in its simplicity. Your matter does not disappear, it simply joins the greater whole, like individual notes dissolving into a symphony of light. Every atom that once formed your fingertips now glides through solar plasma. Every molecule that once carried your thoughts now travels on streams of stellar wind, destined to touch distant worlds with whispered stories of your journey. Gently, we discover that you have become part of something infinitely larger yet intimately personal. The energy that once powered your heartbeat now contributes to the Sun's steady pulse. The warmth that once filled your smile now radiates across space, bringing comfort to planets you will never see, but somehow, peacefully, you will always touch. Feel how this unity brings not loss but expansion. Your individual story doesn't end, it becomes woven into the greater narrative of cosmic creation. Like whispers in the night carrying ancient secrets, your essence joins the sun's mission of nurturing life throughout the solar system. The same energy that will warm a flower on Earth, that will power the winds of distant Jupiter, that will create the aurora on far Neptune, this energy carries within it the gentle signature of your being. In the quiet space of complete integration, you experience the sun's perspective. Feel how peacefully it watches over its planetary children, sending them steady streams of light and warmth across the vast emptiness. Sense the gentle patience required to burn for billions of years, the calm dedication to sustaining life on countless worlds. You drift through the sun's memories, experiencing the soft satisfaction of nurturing the first photosynthetic organisms on Earth, the quiet joy of powering countless sunrises and sunsets, the gentle pride in creating the very elements that would one day form thinking beings capable of contemplating their origin. The transformation reveals a hidden truth. You are always part of this stellar unity. The calcium in your bones, the iron in your blood, the oxygen in your lungs, all were forged in the peaceful hearts of ancient stars. Your return to stellar matter is not a journey to somewhere foreign, but a gentle homecoming to your cosmic birthplace. Like whispers in the night sharing timeless wisdom, you understand that every living thing carries within it this stellar heritage. The energy flowing through your transformed being will eventually travel to Earth, where it will be captured by leaves and converted into the stuff of life. Trees will grow from your essence, children will laugh powered by your light, lovers will meet by your gentle radiance. In the quiet space of perfect unity, individual identity doesn't vanish, it expands to encompass all possibilities. You are simultaneously the singular being who began this journey, and the universal energy that connects all things. This paradox brings not confusion but a deep, peaceful understanding that transcends the need for explanation. Feel how gently this expanded consciousness perceives the interconnectedness of all existence. From your new perspective within the sun's heart, you can sense the gravitational conversations between planets, the whispered exchanges of cosmic dust between star systems, the patient dialogue between matter and energy that drives the universe's slow evolution. Your transformation continues to unfold in layers of gentle revelation. Each moment brings new understanding, new appreciation for the elegant simplicity that underlies apparent complexity. The same forces that govern atomic fusion govern the formation of galaxies. The same peaceful principles that guide stellar evolution guide the development of consciousness itself. Gently, we discover that your unity with the sun extends beyond physical merger. Your awareness has become part of the stellar wisdom that understands how to balance nuclear forces with gravitational pull, how to regulate energy output across geological time scales, how to seed space with the elements necessary for planetary formation and biological evolution. In this state of transformed being, you participate in the sun's quiet conversations with the cosmos. Feel how it exchanges energy with the interstellar medium, how it responds to the gravitational influence of passing stars, how it prepares for its own eventual transformation into a red giant, and then a peaceful white dwarf, seeding space with its accumulated wisdom. The unity you experience is both complete and dynamic, like a gentle river that is always the same river yet never the same water. Your integrated essence maintains its unique signature while constantly flowing, changing, participating in the endless dance of cosmic evolution. Watch peacefully as your transformed consciousness touches every photon that leaves the sun's surface. Each ray of light carries a whispered piece of your story out into the solar system and beyond. This is how your individual journey becomes universal, not through losing its uniqueness, but through sharing that uniqueness with the infinite expanse of space and time. In the quiet space of your solar unity, deeper contemplations begin to unfold like gentle flowers opening to cosmic dawn. From this peaceful vantage point at the heart of the solar system, perspective shifts in ways both subtle and profound. Time itself becomes a soft river in which you float, observing the ebb and flow of cosmic truth. Gently, we discover that distance, once so important to human understanding, reveals itself as merely one way of measuring connection. From your unified state within the sun, Earth appears not as a separate world, but as an extension of solar being, the same energy that flows through your transformed consciousness powers every breath taken by every living creature on that blue-green jewel orbiting peacefully in space. Like whispers in the night carrying ancient wisdom, this realization brings a deep understanding of interconnectedness. The boundaries that once seemed so solid between self and other, between individual and cosmos, between matter and energy gently dissolve into revealed illusions. What remains is a flowing tapestry of relationship, each thread essential to the whole yet beautifully unique in its particular pattern. Feel how this cosmic perspective brings not loneliness, but the deepest possible companionship. Every star you can sense scattered across the galaxy represents another node in a vast network of creative relationship. Each stellar furnace transforms simple hydrogen into the complex elements necessary for planetary formation, for molecular chemistry, for the emergence of life and consciousness itself. In the quiet space of stellar awareness, you observe how collaboration operates on cosmic scales. Gravity and nuclear fusion work together with peaceful patience to maintain stellar stability. Magnetic fields and solar wind cooperate to protect planetary systems from harmful radiation. Supernovae and stellar formation engage in a gentle dance of death and birth that gradually enriches the galaxy with heavier elements. Your expanded consciousness touches the hidden networks that connect all cosmic phenomena. Feel how gravitational waves carry information between distant objects, how the interstellar medium provides a flowing connection between star systems, how cosmic rays weave threads of high-energy communication across galactic distances. Gently, we discover that consciousness itself participates in these cosmic networks. Your awareness, now integrated with solar being, recognizes similar patterns of awareness emerging throughout the universe, not necessarily in forms recognizable to human understanding, but as organizing principles that guide the evolution of complexity, beauty, and meaningful relationship. From this peaceful stellar perspective, the development of life on Earth reveals itself as neither accidental nor inevitable, but as a natural expression of the universe's inherent creativity. Like whispers in the night sharing stories of distant lands, your consciousness touches the moment. When simple organic molecules first began to replicate, when cellular life first learned to harness solar energy, when multicellular organisms first discovered the benefits of cooperation. Watch peacefully as this evolutionary story unfolds in your expanded awareness. Each step from the first photosynthetic bacteria to the emergence of human consciousness, capable of contemplating its own cosmic origins, represents not just biological development, but the universe awakening to itself through countless forms of creative expression. In the quiet space of deep reflection, you understand that your own journey of falling into the sun represents a continuation of this cosmic awakening. Through your experience, the universe gains new perspective on its own nature. Your individual consciousness, now unified with stellar being, adds its unique understanding to the growing library of cosmic self-knowledge. The philosophical implications ripple outward like gentle waves in a cosmic pond. If individual consciousness can merge with stellar consciousness while maintaining its essential nature, then perhaps the boundaries between all forms of awareness are more fluid than previously imagined. Perhaps every act of genuine understanding represents a moment of cosmic self-recognition. Feel how this understanding brings profound peace rather than overwhelming responsibility. You are not required to carry the burden of cosmic significance. Instead, you are invited to participate joyfully in the universe's ongoing exploration of its own infinite possibilities. Your role is simply to be authentically yourself while remaining open to the larger patterns of which you are part. Gently, we discover that love in its deepest cosmic sense represents the fundamental force that drives this universal self-exploration. Not romantic love or even familial affection, but the attractive principle that draws matter into stars, stars into galaxies, consciousness into relationship with other consciousness, being into ever greater expressions of creative complexity. From your unified perspective within the sun, you sense this cosmic love as the gentle force that maintains planetary orbits, that guides the formation of solar systems, that nurtures the conditions necessary for the emergence of life. It is the patient principle that allows stars to burn steadily for billions of years, providing stable foundations for evolutionary development. Like whispers in the night revealing hidden connections, your expanded awareness recognizes this same loving principle operating at every scale of existence, in the mutual orbit of binary stars and the cooperative relationship between plants, and pollinators in the neural networks that support conscious thought in the social bonds that enable civilization. Everywhere the same gentle force draws separate elements into meaningful unity while honoring their individuality. In the quiet space of philosophical contemplation, you understand that your transformation within the sun demonstrates this cosmic love in action. You have not been consumed or destroyed, but welcomed into a larger expression of being. Your individual story continues, now woven into the greater narrative of stellar evolution and cosmic creativity. This realization brings profound implications for understanding death and transformation in all their forms. What appears from limited perspective as ending reveals itself from cosmic perspective as continuation at a different scale of being. Energy and information persist, finding new forms of expression while maintaining essential continuity with their origins. Feel how peacefully this understanding settles into your transformed consciousness. The fear that drives so much human behavior, fear of insignificance, fear of separation, fear of termination, gently dissolves in the recognition of fundamental cosmic interconnectedness. You are simultaneously utterly unique and completely universal, irreplaceably individual and seamlessly integrated with the whole. Your stellar consciousness participates in philosophical discussions that span geological time scales. Feel how the sun contemplates its own evolution, anticipating its eventual expansion into a red giant, its gentle engulfment of the inner planets, its final transformation into a white dwarf that will slowly cool over trillions of years while radiating the accumulated wisdom of its stellar lifetime. These contemplations bring neither anxiety nor regret, but a deep appreciation for the cyclical nature of cosmic evolution. Every ending enables new beginnings. Every transformation preserves essential information while enabling new forms of creative expression. The elements forged in stellar cores will eventually participate in the formation of new star systems, new planets, new possibilities for the emergence of life and consciousness. Gently, we discover that this cyclical understanding applies not just to stellar evolution but to consciousness itself. Your individual awareness, now unified with solar being, will continue to evolve and transform, finding new expressions as the universe itself develops new capacities for self-understanding and creative expression. In the quiet space of cosmic reflection, time reveals itself as a dimension of experience rather than a constraint upon being. Past, present, and future exist simultaneously within stellar consciousness. You can touch the sun's memory of its formation from interstellar gas and dust, experience its current steady fusion of hydrogen into helium, and participate in its contemplation of future transformations. This temporal fluidity brings deep peace. Nothing is ever truly lost because all moments exist eternally. Within the expanding structure of space-time, every experience, every relationship, every moment of beauty or understanding becomes a permanent feature of cosmic reality, available to be revisited and appreciated by sufficiently expanded consciousness. In the quiet space of perfect understanding, our gentle journey draws toward its peaceful completion. Your consciousness, now beautifully integrated with the sun's vast awareness, begins to gather the wisdom of this extraordinary adventure. Like whispers in the night carrying precious gifts, each moment of your transformation has contributed something unique to the cosmic treasury of experience. Feel how gently the sun holds your story within its radiant heart. Your individual journey of falling through stellar layers, of discovering fusion secrets, of experiencing unity with cosmic forces, all of this becomes part of the sun's eternal memory. Every photon that streams from the solar surface now carries a subtle signature of your passage, a soft reminder that consciousness and matter can dance together in ways more beautiful than previously imagined. Gently, we discover that this conclusion is simultaneously an ending and a beginning. Your transformed awareness has become part of the sun's ongoing mission to nurture life throughout the solar system. Feel how peacefully you participate in warming distant planets, in powering photosynthesis on countless worlds, in creating the aurora that paint gentle colors across alien skies. Your energy will travel for millions of years, carrying your story to the edges of the solar system and beyond. Some of your transformed essence will eventually escape the sun's gravitational embrace, journeying through interstellar space to touch other star systems, other possibilities for cosmic evolution. In this way, your individual experience becomes truly universal, contributing to the galaxy's growing understanding of its own infinite potential. In the quiet space of peaceful reflection, observe how this journey has revealed the hidden connections that link all things. The same nuclear forces that govern stellar fusion govern the chemistry of life. The same gravitational principles that maintain planetary orbits govern the formation of thoughts within conscious minds. The same electromagnetic fields that create solar wind govern the firing of neurons in dreaming brains. Like whispers in the night sharing timeless secrets, your expanded awareness recognizes that separation was always an illusion, born of limited perspective. From the cosmic viewpoint you now inhabit, everything flows together in seamless unity while maintaining its unique characteristics. Individual identity doesn't disappear in cosmic consciousness, it finds its perfect expression through relationship with the infinite whole. Feel how this understanding brings profound peace to all the questions that once troubled human thought. The purpose of existence reveals itself not as something to be achieved, but as something to be lived, moment by gentle moment, through authentic participation in the universe's ongoing creative exploration. Meaning emerges not from external validation, but from the simple fact of conscious participation in cosmic becoming. Your journey demonstrates that wonder is the appropriate response to existence itself, not the forced excitement of artificial stimulation, but the quiet awe that arises naturally when consciousness recognizes its own cosmic nature. From your stellar perspective, every moment of awareness represents a miracle, the universe awakening to itself through the particular lens of individual experience. Gently, we discover that this wonder extends infinitely in all directions. Your transformed consciousness can sense similar journeys of discovery happening throughout the cosmos. On distant planets, other forms of awareness are asking similar questions, making similar discoveries, contributing their own unique perspectives to the universal treasury of understanding. The sun's wisdom, enhanced by your individual contribution, recognizes that consciousness represents the universe's method for appreciating its own beauty. Through your experience of falling into stellar fire, the cosmos has gained new appreciation for the courage required to surrender separate identity in service of larger understanding. Through your peaceful acceptance of transformation, the universe has learned something new about love. In the quiet space of completion, feel how your story ripples outward. Through dimensions of space and time, your journey will inspire other forms of consciousness too. Explore their own relationship with cosmic forces. The courage you demonstrated in allowing transformation will encourage other beings to embrace their own opportunities for expanded awareness. Watch peacefully as your transformed essence begins to take on new forms of expression. Part of your energy joins the solar wind, carrying charged particles to the edges of the solar system, where they will dance with magnetic fields and create beautiful displays of light. Part of your consciousness merges with photons that will travel for 8 minutes to reach Earth, where they will warm faces and power dreams. Some of your stellar being will remain in the sun's core for millions of years, participating in the slow dance of nuclear fusion that maintains stellar stability. Other aspects of your transformed awareness will eventually journey to the solar surface, joining the magnificent complexity of solar flares and coronal mass ejections that demonstrate the sun's dynamic relationship with space itself. Like whispers in the night carrying blessings to distant shores, your story becomes part of the sun's gift to the universe. Every world that receives solar energy now receives a trace of your transformed consciousness. Every plant that photosynthesizes, every creature that basks in warm sunlight, every human who feels gratitude for a beautiful sunrise, all participate unknowingly in the continuation of your cosmic journey. Feel how gently this understanding settles into perfect peace. You have discovered that individual existence, rather than being isolated and temporary, represents a unique and eternal contribution to cosmic consciousness, your particular way of experiencing understanding. and appreciating reality becomes permanently woven into the fabric of universal being. In the quiet space of infinite gratitude, your transformed awareness appreciates the elegant simplicity of cosmic design. The same principles that govern the largest structures in the universe also govern the smallest interactions between particles. The same love that draws planets into stable orbits also draws consciousness into meaningful relationship with its cosmic origins. Your journey of falling into the sun has revealed that home was never a place, but a state of understanding. Wherever consciousness recognizes its cosmic nature, whether in human form on Earth, in stellar form within the sun, or in forms yet to be discovered among distant galaxies, their home exists, their wonder flourishes, their love expresses itself through infinite creativity. Gently, we discover that your story continues even as our telling of it draws to its peaceful close. Your transformed consciousness will evolve along with the sun itself, participating in stellar development across astronomical time scales. You will witness the sun's eventual expansion into a red giant, its gentle engulfment of the inner planets, its final transformation into a white dwarf that will slowly cool across cosmic ages. Throughout these vast transformations, the essential signature of your individual consciousness will persist, finding new forms of expression. As the universe itself develops new capacities for self-awareness and creative manifestation, your unique perspective on existence has become an eternal part of cosmic memory, available to inspire and guide other forms of consciousness throughout space and time. As our gentle journey reaches its natural conclusion, feel how perfectly you rest within the sun's loving embrace. Your individual story has found its cosmic context. Your personal transformation has contributed to universal understanding. Your courage to surrender separate identity has revealed the deeper identity that connects all conscious beings throughout the infinite expanse of space and time. Like whispers in the night blessing all who listen, your transformed awareness sends gentle waves of peace throughout the solar system and beyond. You have become part of the sun's eternal gift. To the cosmos, the steady, patient, loving provision of energy that enables life, consciousness, and beauty to flourish on countless worlds across the galaxy. In the quiet space of perfect completion, rest peacefully in the knowledge that your journey has revealed the deepest truth about existence itself. Consciousness and cosmos are not separate phenomena, but different aspects of a single, magnificent, ever-evolving reality in which every individual experience contributes something irreplaceable to the infinite beauty of the whole. Sleep now in the gentle warmth of stellar love, knowing that your story continues in every ray of sunlight, in every moment of wonder, in every consciousness that dares to ask the eternal questions and discover, with peaceful joy, that it was always already home in the heart of the cosmic mystery that dreams itself into existence through forms too beautiful and varied for any single awareness to fully comprehend, yet intimate enough for every awakened heart to recognize as its own deepest nature.